Hello everyone, and welcome back to the Intense Crash Course in Objective-C. This is Week 2, Part 2. So basically, the first part of Week 2 ended up becoming a monster of a session. So we decided to split it up into two different sessions, and it looks like the majority of the students were able to make it back today. I think that's absolutely fantastic. It's really cool that you guys are able to hang out with us once again. As a matter of fact, we have literally almost every single person back, so that's really cool. I will try to keep tonight from being 5 hours long. It shouldn't be. I mean, it really shouldn't be. But we are now getting into the second part of Week 2. And if you guys recall, the second part was all about functions. So let's go ahead and practice our writing skills. Functions. All right, well, that's not too terribly bad for tonight. Good. So we've got a few different things that we're going to be covering. We're going to first start out with what exactly is a function. And remember, I'm targeting this to those of you that are completely new to programming. So those of you that have experience working with functions or in other applications where you're dealing with classes, methods, you're going to be bored. This is where, turn TV on and tune me out. All right, good. So yeah, we're going to be talking about what functions are. And so we'll go over the definition of a function. We're going to take a look at function definition syntax. We're going to talk about declaring functions, so that means we'll be getting into function prototypes. We're going to talk about the different types of functions. We're going to talk about recursion, because there's no way that we could let tonight go by without a discussion on recursion, because that's fun stuff. I mean, it's really fun stuff. We're also going to take a look at the stack tonight. And some people have said in the past I'm a bit crazy when I want to get into discussing the program execution stack. I'm not going to get really deep into it, but I really would like to give enough of an explanation that you guys understand why variable scope works the way it does once we start working with functions, because scope becomes so critically important. And of course, we will be talking about scope as well. So that's what we've got planned for tonight. So the very first thing I want to do is talk about what a function is. Now, we've already mentioned this. When I teach classes, as we work towards more advanced subjects, I really like trying to slip terminology in and make mentions of things that are to come in later sessions. And if you guys recall from week 1, I mentioned functions several times, gave a very general overview of what functions were. We talked about recipes, if you guys recall. I looked at basic syntax. We talked a little bit about parameters, a little bit about return types. So those were all seeds that have been planted in the heads of those of you that are new to programming. So tonight, I shall sprinkle water on it, and hopefully we shall have functions sprouting from your head, and you'll have a clear understanding of what's going on by the end of class. What? Come on, think artistically, Nelson, now that you're wanting to call yourself an artist. Yeah.
Hey, I never said I was an artist.
Oh, jeez. So what is a function? A function is basically a self-contained block of code with a specific task that it accomplishes. Here's how I shall draw my function. There we go. We'll say this is main. Whoop. Main is a very special function. We all know that now. We all know that well. It is the entry point into our application. At this point, we all also know that since C is case sensitive, main with a lowercase m is what is important for entry into the application as far as execution is concerned. Main like this, to use Nelson's favorite words, would be dumb. You should never even do that. One, this would not serve as an entry point. Now your program's going to have an error when you try to build it if you don't have a main with a lowercase in there. But if you were to have another function with the name main like this, and of course you have the small version of main, the actual entry point, that would just be very, very bad. So please keep that in mind. So main functions. Well, since main's our entry point, it kind of kicks off the whole program, if you will. You don't want functions to have a lot of code in them. We want small functions. And we're going to see why here in just a moment. So main's going to kick off, and inside of it, I mean, we've been using it up to this point just to demonstrate language features, and we're going to continue doing that. But now that you guys are armed with the knowledge of how to do flow control through if statements and loops, after you get functions under your belt, we're going to start writing new functions, and generally inside of main, we're going to be quickly passing execution off to other functions, which in turn will be calling upon other functions. So inside of main, you'll find generally a small amount of code, and that code is the heart of your application. But we quickly leave out of main and pass control over to other functions, and we're going to see how to do that tonight. So very simple definition. It's just a self-contained block of code. Now, the nice thing about having a function, we saw with loops that by putting a block of statements into a loop, we were able to repeat code without having to retype the code. Functions give us the same kind of thing. We don't have to retype a specific set of statements to do a particular task over and over and over. Instead, we could simply take those statements and put them inside of a function, and then we just call that function anytime we want those tasks to execute. And it makes life a lot easier for us so that we don't have to go around reinventing the wheel all the time. And we've already seen that. With the C standard library, there have been a lot of functions that have already been created for us and made available through that library. And we've been using a few of them, especially printf. We've all but worn it out. And scanf we've used. But, having those things available to us keep us from having to go out and reinvent the wheel. So as we get better with our own programming, we can start building our own library. So as you start writing useful utilities that you may find yourself wanting to utilize in multiple applications, then you can start packaging all of your stuff up in libraries and make use of those libraries, so then you don't even have to rewrite that functionality as you start working on other programs. So Nelson, is there anything you'd like to add into just the basic overview of what a function is? Oh, other than,
No.
well, I do. You were going to add
Fine,
this.
I guess I don't.
Well, but I do want to throw this in too. So
That's what I was going to
whatever. You just said you didn't have anything to add. Debugging. Readability. By creating functions with names that make sense for the specific task that the function will do helps with readability. By keeping functions nice and small, again, it helps significantly with readability when going back over a program and reading it. And then, more importantly, when it comes to troubleshooting, when you have a problem, if you were to code everything in a single function, and then you had to go and let's say you used gotos or something.
It'd be awesome.
Oh, no, it'd be horrible.
Not using gotos, but a single function. Yeah.
Thought you were about to say using gotos. I was going to get up and go smack you real quick. Notice how I haven't even talked about gotos. But anyways, if you ran into a problem and you had this main function that was pages and pages and pages long, finding the bug could really become a difficult task. It could really start giving you headaches. But having everything divided up into functions, you know what task is giving you trouble, and you know right where you need to go and start looking for the problem. And if you follow the general rule of keeping your functions small, you shouldn't have much code to actually look through in order to find the problem. So functions, very, very helpful. Now, let me ask one more time. Nelson, is there anything you would like to add into that?
No, not particularly. I mean, at the very, very basic level, a function is really just a block of code. And it's really nice in programming to construct your functions at varying, I guess you could say, levels, to where, like I said before, I used the chain of command analogy, where you might have a very high-level function that tells other functions to do their tasks. That function doesn't know how to do those tasks, but that keeps the code really clean and succinct. And then those other functions are then responsible for performing the individual, more specific and specialized tasks.
Exactly. So in making use of functions, there's a few things that we need to know before we take a look at basic syntax. And that is, first, functions must be defined.
Yeah, I do want to point out that requirement extends to pretty much everything in C.
Yeah.
You're pretty much going to have to define everything that you use in C, and I just wanted to throw that out there because there are many languages where that's not the case.
Okay, after the function is defined, declared. Now, depending on where you actually define your function at, it may serve as the declaration as well. If the function is defined prior to a function that is going to call on it, then it's also been declared. That function that will make use of a function that has been previously defined above it in your source file, it knows about it because it came first. So it's been declared. But generally, that's not how we're going to be working, and we don't want to have to think that way. So I want you to know that they've got to be defined, and we've got to declare them because we're going to be talking about prototypes and getting our functions declared. And you're already using header files at this point to declare functions that you intend to use, such as printf and scanf. So after we've got functions defined and declared, we use them. How do we use them? We call them, or we invoke them. Two words you're going to hear quite a bit. And generally, I just say call most of the time. So to me, it's a function call. We're going to do a function call. And what that does is it passes execution off to the new function. So let's say that I had another function down here that was called, I don't know, we'll call it add. And it took in some data. So it had two parameters, and we'll get into the specifics of how that's all set up here shortly. I'm just wanting to keep my drawing really simple. So we're cruising along in main, and main already knows about the add function because it has been declared. So main knows about it. So when main goes to actually make use of add and sends a couple of things over.
Could you satisfy my OCD real fast, Jason?
What?
Please? Unless this completely...
Don't tell me you're wanting me to throw return types over there as well.
No. Just if this doesn't completely throw off your diagram, could you swap main and add?
What? I just said, jeez.
Okay, we'll put it up there. Okay, sorry.
Jeez, now you're wanting me to actually write the whole thing out. I was just trying to use, So now it's been prototyped. It's been declared, so main knows about it. So now I can make use of it. So when we actually call on another function, execution is now passed off to add. So again, we called or invoked the add function. Execution executes linearly. When we get to the very end, we return back to the caller, because there still could potentially be more that needs to be done on this line that's being executed. In this case, there's not. So from here, execution would then go on to the next line and continue. Very straightforward. Wouldn't you agree? What do you think, Nina?
It goes back and it continues.
And it just continues.
And it continues.
So an example I used to use a long time ago, you know how to do the task of washing dishes, correct?
Right.
Okay. So let's say that you're sitting in there watching TV, and I invoke the Nina, go wash dishes functionality. Nina, go wash dishes.
Okay.
I don't have to know anything about how to wash dishes. You know that.
Right.
So you get up. You remember that you were sitting there on the couch watching TV, and you walk into the kitchen and you do everything that you need to do to wash dishes. And then once you get done washing dishes, you're now done with that task, that functionality, and you return back to the couch and you continue watching your favorite show of whatever it may be. It's that simple. Now, you could be in the middle of washing dishes, and in washing those dishes, you come across a pan that needs to be I don't know, you need to put gasoline in it and set it on fire because it's just this horrible thing. And that's another task that you know how to do. It's like, oh my goodness, look at this pen. It's got dead crawly things in it, and they just need to be burned. It's little like maggots. I can't believe I just said that. So I know how to call upon that task. So now you could call upon the task in yourself. It's like, I need to burn the contents of this. So now you switch over to burn contents of, and you send it the pot. So now we've sent over some information. Like here we saw,
Could that be an if-else if contents have maggots?
Well, yeah, but in your function as we're working through wash dishes, absolutely. With each dish that you're washing, you have an if. If dish filled with maggots, I'm going to call on the burn dish functionality, and I'm going to pass this dish as the argument to it. So here, for add, obviously I'm going to be passing two numbers over. In the thing that I'm describing with you, this burn dish functionality, the argument that it would be expecting is going to be a dish. So you'd call upon that. Now you're going to remember where you were washing dishes. So at this point, this is Nina's burn dish task. Burn.
When we get the flamethrower we made in Maya today.
It's expecting a dish to be sent over. So she's like washing dishes and she's going through her stuff, and this one's got dead stuff in it. So we're now going to call upon burn dish, and notice we're actually sending over the dish. And this is a whole new task. Take dish, set it to the side, pull out the gasoline from up underneath the sink, pour gasoline in dish, light.
You have gasoline in your sink?
Well, if you're going to be burning our dishes, I would sure hope you keep gasoline someplace near the sink. Now, the dish is now aflame. She's at the end of the method.
So then it returns.
It returns, but where do we return back to?
I would say to the beginning, right?
It returns back to, what did I say over here about with the calling and all? We return back to whoever invoked, whoever called. And I also pointed this out with the add.
Back to
we
you.
return back to the caller. So say right here is where you call burn. That's a burn in there. I promise you guys. And then we'll put these little, parentheses around it to make it look all, preventing Nelson's OCD from exploding. And we'll draw a teacup. There we go. That's our teacup, and which we've sent over to be burned. And it's been burned. We've gone through this method. Execution is now done. Cup is a-flaming, and we're happy. So since we've now reached the end, we return back to the caller, which is this guy.
Okay.
Because that's the guy that invoked burn.
Okay, so you have to return back to the invoker of burn.
And Exion official said there's a burn inside of add, and that's correct. So to make this particular example make more sense, instead of calling it burn, it could have been, wash dishes. And then you could even have said take in all of the dishes. And then you're going to loop through those dishes and wash each one at a time. Wash each one at a time. Oh, there we go. My brain was about to explode. And then as we're washing them, so we're using that really cool loop stuff that you guys learned a couple nights ago, if we happen to stumble on one that needs to be burned,
then it will invoke.
Then we will invoke this function. Look at Nina talking all programming like now.
Word.
We'll perform the task of burning that dish. Once we hit the end, we then return back to where we were, and we continue executing because remember, we were in the middle of working our way through a set of dishes. What if the very first dish was covered with horrible dead or live squirmy things? Then you right away, you jump down, you burn it, you come back, and you continue with the next dish. You may have to burn all the dishes. Who knows, right? But the thing is we continue staying inside of Nina's wash dishes task that she knows about until we finally are done with the execution inside it. And when we're done, then we return back to whoever called it. In this case, it's back to Nina's main life, which happened to be sitting and watching TV at that point in time when I invoked her wash dishes task. Kind of make sense?
Yes.
Yes. So you guys are going to now have horrid nightmares about burning dishes and little squirmy things.
Dishes.
Oh, I don't even know if Angela is listening. Oh, she is. Oh, geez. Okay, so she's like, keep the gasoline away. So there's one other thing now. I want to just point it out right now, and that is we saw that as execution was being passed around, so now if we come back over here to my giant mess of a whiteboard, we saw I drew everything in little boxes, right? And we saw that we would pass execution off to another box, another function. And when we do that, remember how here I said with add, we sent two numbers to it, and then we came back and we changed it to wash dishes to kind of match the analogy that I'm using. And so we said pass dishes to it. Here's an interesting thing that you need to understand with C, because I know for a fact that there's a lot of you out there that I'm looking at right now over in BuzzNet that are used to other applications, and you're used to the terms pass by value and pass by reference. In C, we can only pass by value. We can simulate pass by reference, and we simulate that by passing around pointers. And that's something that we'll get into. Well, I guess we'll start talking about that next week. Yeah, that's when things get really fun.
You said the P word.
I did. I'm sorry. But next week we're getting into it, so come on. So yeah, using pointers, we simulate. And you guys have done it. Come on, think about it. Remember, we called scanf. And so here we are in Maine, right? We're cruising through Maine. I got to, by the way, when I'm writing really horrible like that, that's because I'm looking at a different monitor that's receiving the feed from the webinar, so it's running like a second and a half behind. I got to remember to look over here to the left at my Mac when I'm drawing so I get real-time drawing updates. There we go. So here we are. We're inside of Maine. We're having a good time. We're doing stuff. And then we need to what was I talking about again? We need to. No, this. I'm testing Nina. What were we talking about?
We were talking about
Invoking
the function, right? Wait,
we were talking about pointers.
Well,
Come
I'm
on.
sorry, pointers. Okay.
Remember,
pointers.
I'm planting seeds.
Okay.
I want to know
Pointers
that the
for
P
next
word.
week. Okay, I'm sorry. I thought
That's
we were
right,
not
but I
talking
want to
about
know
the P
that the
word.
P word is in your head.
Okay.
I'm sorry, guys. I saw Nina's eyes kind of glassing over. We're cruising along, and now we got to use scanf.
Oh, okay.
And we saw with scanf, so we're taking a number in, and we use that. Let's say we had an int num. Oops, num does not look like an M. Tried to write it backwards. And we saw that we use that dereferencing operator, that special, now I said the D word, Nelson, that special ampersand that's like, why do we have this crazy symbol here? Well, because since we're now all function experts, we know that we're calling the function scanf. Where does scanf reside, Nina?
Oh, God. I'm sorry. Where does scanf reside?
Help her out, Ashley. Do it.
In
do
the
it.
function?
Well, it is a function.
It's a
Not
function.
in a function. It is a function.
It resides.
Did I write scanf?
Yes.
Mr. Lewis, you're all over this. Where did I write scanf at?
Oh.
It's in the standard input-output library. Remember at the beginning of our program?
Yeah,
no, that's okay. That's okay.
This guy up here.
Ashley, don't you be laughing at her. I didn't see you jump in there and throw stuff. You need to be thanking Mr. Lewis right now, who just came and rescued you, who were supposed to be rescuing poor Nina. Wasn't listening.
This
all right.
guy.
We're calling only on Ashley for the rest of the night. That's right. We're the standard input-output library or header that we're making use of in the standard C library.
That's right. Okay.
It's already been written for us. We're making use of it. But look, the bottom line is it's a function. So what happens when we invoke a function, when we call a function, we're passing execution off to this guy. Now, inside of the scanf function, this is us back here in Maine, and I am drawing a daggum smiley face on it to prove it's us. That's us. We don't know anything about what's going on inside of scanf. But what we do know is that we want data to end up in one of our variables, the variable that we called num. Because remember, when we use scanf, remember how that works? Since it looks so horrible up there. Scanf, and then we use our format specifier.
%D.
And then we used a comma. And then we couldn't just do this. because if we do this, we're going to get ourselves in some serious trouble. Yeah, we had to put this special little symbol in there. And if you guys recall, and then a terminator, if you guys recall, this is dereferencing num. What this is doing is it's sending the address of where num is over to scanf. So scanf now can see, he can see all of the program's allotted memory in the program execution stack. It now knows, it's like, we're going to do all this really complicated, crazy stuff in our laboratory, where on a screen, we're going to be giving you a little place to type a number in. And when you type that number in and you hit enter, it now knows, there's num. I'm actually drawing the little memory location. It knows to put that here, because it has the actual address of that. When we use our mailbox, we know where our mailbox is. It's right out front. It's local. It's our mailbox. We walk out to it. We open it up. We pull our mail out, or we put mail in it to be picked up by the postman. But if I said, I want you, Nina, to put this here in Ashley's mailbox. Now, all you know is that Ashley is an adorable young lady who hangs out on Facebook and hangs out on 3D
But
Buzz.
I don't know where her mailbox is.
But you don't know where her mailbox is for real. I need to give you the address of that mailbox, and then you could do it, couldn't you?
Right.
Same thing. That is exactly what's going on here. So what I'm starting to slowly get at here is that when you are working with variables, these variables are self-contained. They're local. Now, for those of you that know what global variables are, we'll talk about global variables later. They kind of make me gag, and that's not cool when I'm recording myself talking like this. Global variables are bad. There are times when they can be useful, but my philosophy has always been rewrite your darn code, refactor it so that you don't have to use a global. So, continuing on. Pass by value. So, since we are passing by value, we are sending a copy. So, back to this example with add over here. Remember when I called add and I passed X and Y to it? So let's say that X contained a 5 and Y contained a 6. I actually copied this data. The data exists a second time in memory. And I sent that data. That data gets sent over here to this function. And we're going to take a look at the program execution stack here shortly. And I think I'll be able to make it make a lot of sense to you guys, because you'll get a much clearer picture of what really is happening in the computer when you're executing your program. But so at this point in time, while we are inside the add function, so let's pretend this here is still called add, not wash dishes. So while we are inside that box, it has its own copy of X equals 5 and Y equals 6, if I happen to call the parameters those names. But here's the key thing. Like if I took X here and suddenly changed it to say X equals 22, and then we hit the end of our program, and we return back to the caller, which as you guys know will take us back up to main, because that's where we called add from. Back inside of main, X and Y did not change. Okay? And TF242, hey my good friend, I didn't see you sneak in, and we talked about short-circuiting quite a bit the other night, for the record.
Yep.
Hola. So continuing on, when I changed X down here in a different function, it did not change it back in main. It was a copy of the data that we worked with. And again, if right now you're feeling a little confused, and I only say that because I see the confusion in the lovely Nina's face.
Oh, no, I'm concentrating. That's
a
major.
concentration
I'm
look.
trying to
That's
get
awesome.
this.
Okay. So, and I see that Ashley's somewhere right now across a few states flirting with Brian. Pay attention, Ashley.
But no, I get it.
Okay, it is a copy of the data. So again, for those of you in the class that have programming experience in other languages, such as C#, and you know that you can pass by value and you can pass by reference, here we're just in C, we can only pass by value. We can, and that means we're going to make a copy of the data. That copy happens for us automatically, and you guys are going to see how that happens when we start talking about the stack. But it happens automatically, but it is a copy. With pointers, we can simulate passing by reference. Okay? All right, so now moving on, so that we've taken a look at a few things. The final thing that I'm just going to jot down right here is going to be our stack. And this is sometimes referred to the function call stack. What it actually is. Oh, I love it. Mr.
That's Marvin.
Make Marvin. Awesome. I'm glad you're confused. Hang in there, though, because this is going to start making more and more sense in a minute. Right now, pretend I'm a farmer. I'm planting seeds, but unfortunately, I'm planting seeds right now with a bulldozer. I'm doing a messy job all over the place, and I will start bringing it all together as we progress through tonight's class. It's going to make a lot of sense, I promise you. And Mr. TF242, thank you very much, sir. I just saw your compliment on the class so far. But this will all become very clear, as Thomas just said himself. So I'm glad to hear that somebody's confused. That makes me feel good. Okay? So this stack is sometimes referred to as the function call stack. And then also, I mean, what it really is, it's the program execution stack. That's what it really is. Okay, but if you say function call stack, I guess it may come down to context in which you're using it in, because generally when you're referring to the function call stack, you're referring to stack frames, which will make sense also very shortly. But again, context. But if you use either of these two, it's completely cool. I just wanted to point that out. So now I have thrown terminology up against the wall as hard as I can, and you can pretend that all of this terminology is kind of like water balloons filled with different colored paints. So right now, my wall just looks nasty. Well, or if you're artistic, it might look quite sexy, but it's a mess. So now let's go ahead and start fine-tuning this mess. Let's start smearing that paint around and make something out of it that makes a little bit more sense than just this abstract, as Mr. Exion Official said, contemporary art. So that's what we're going to do. And we'll start this off by looking at function definition syntax. So I'm going to go ahead and make myself a little bit more room here. And let's do like we did last night, syntax. Not last night, but Tuesday night. You guys know what I mean. It all blurs together for me. So the basic syntax goes like this. Return type. The function name, I'm just going to say identifier. We're identifying the function, but remember, function, I'm just going to call it fun. Yay! Name. We having fun yet, guys?
So
good.
The identifier,
if not, lie to me.
Identifier is the function name.
Yeah, it's just like with variables. An identifier is it's just identifying a variable or identifying a particular function, or there's all sorts of things we'll be using identifiers for later. So next we have an open parentheses, and then we have our parameter list. And then our parameter list, so right now I simplified the heck out of the parameter list. I mean, what it really looks like is going to be the type, space, and then an identifier, comma, dot, 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 type identifier, forever, however many types that you want, however many parameters you want this function to take in. And then finally, I'll just say the last one, which we could say is type in, if you will, but it ends with type and an identifier. And then a closing parentheses. This is our parameter list. Here is something that I have seen a lot of people. In fact, it was funny because Nelson quizzed me on it earlier, and I completely agree with what he said. Of course, I didn't miss a beat when he said, what's the difference between a parameter and an argument? Because you're going to hear these two words. Nelson, I just heard you hit unmute. Go ahead.
Well, I mean, yeah, it's something that people really often get confused about. But a parameter and an argument are not the same thing.
No.
A parameter is something that you define in the function definition. Wow, words.
All right, here, I'll take care of it. I just heard you unmute. I was going to explain it. I wasn't looking for you to, but go ahead then.
Oh, well, no, okay, you can do it. I mean,
well, no, I was just going to say when you're defining a function, and see, we're writing out the syntax here. This right here, these are parameters. Arguments, that's data. That's these guys right here, this parameter list, this is not data. These are parameters. These are guys that will receive data. They'll be populated with data. Arguments are actual data. It's data that gets sent off to parameters. Okay, so if you remember arguments as being data and parameters as being the definition of variables that will be receiving data, you'll be in good shape. Now, Nelson, was there anything you wanted to add to that?
No, that's, yeah, that
okay.
Works.
Okay, cool. But I totally agreed with Nelson when he asked me that earlier. A lot of people get confused with that. So, and Mr. Marvin, we will have plenty of examples coming up in just a minute. Because believe it or not, I am not yet done with the syntax. All we've done at this point, you could look at it as basically declared our method. Our excuse me, function. Now we need our function body. So we've already discussed in week 1 with main, when we looked very carefully at main, that all functions that are defined always have an open and a closing curly brace. Now, inside of the open and closing curly brace, this is where we have, any, I'm just going to write it as local variables. All optional, of course. If you need local variables, you define your local variables in there. And then statements. So, I mean, we've got to have code, right? That's the whole point of having a method and please forgive me when I accidentally say method. We will be discussing methods this coming up Tuesday when we switch over to Objective-C and we get into the object-oriented world. In C, we do not have methods. They are functions, but they look exactly the same, but we'll be talking about that next week. So function. So here we are, statement, lots of statements, and then a return and perhaps a value if we're supposed to be returning something back out. Okay? And we don't have to have a return. If we're not going to send anything back out, we'll just execute until we hit the end of the function, and then it's the end. We jump back out. Okay, so it's very straightforward. If I wanted to write a function that just said hello world, you guys remember we did the hello, it was hello nothing is what we did on the first week. Well, let's say we wanted to put that task off into a function. We could do that by defining a function that looked like this. So we have a return type. What would be returned from hello world? Nothing. Don't get confused with the idea of, well, it's going to say hello world, so is it returning hello world?
Okay.
No, hello world is just going to write it out to our screen.
And that's not a return.
So what would it return? What is this? What would you guess it returned? Nothing.
Nothing.
So how do we represent nothing? That's right, Mr. Lewis. He's all over this. Void.
Oh.
So we've seen types like int and long and doubles and chars and things like that. We also have this guy called void. And void is just that. Is nothing. So this is how we would represent nothing. So we're going to say void because we're not going to be returning anything. And now we need to come up with a friendly name, a name that makes sense for what the task does. Fortunately, with Nina, she knows how to wash dishes, and she can associate the governing name of wash dishes as the task name that needs to be called upon in order for her to go and wash dishes, for her to perform the series of tasks all wrapped up in washing dishes. So we need to come up with an identifier for this function that makes sense. So I could say, I want to say print, but and I'll just say, yeah, forget it. Print hello world. So far we're following our syntax: a return type, an identifier, parameter list time. So we've got to have an open parentheses now. Parameter lists are optional. If you do not have a parameter list, it looks like that. Go ahead, Nelson.
I would possibly rephrase that and say that parameter lists aren't optional, but they can contain no parameters. Just because I don't want people to think they can omit the open and close parenthesis.
That's what I was just saying. I don't want to. No, you cannot. I don't want them to assume that because I'm outright saying you cannot omit them. You have to have the open and closing parentheses in there, but you do not have to have a parameter list in there.
Okay.
You don't have a problem with that, do you? Because that's how I was explaining.
No.
Okay.
That's fine.
They're optional, as in they're optional for you to define a parameter list or not. So, but you have to have, again, following the syntax set out above, we have to have the open and closing parentheses in there. What do we have to have next? Come on, Marvin. Tell me, my good friend.
Terminator?
Terminator? Nina,
Wait,
where's...
what?
I need a bag.
Oh, no.
Right.
Wow!
Exion, where is my whip?
Oh, no.
What comes next?
Comes next in this one.
A curly brace.
Oh, jeez.
Okay, so Marvin said
I thought
bracket.
we were done.
I'm not a fan of brackets. Thank you, Mr. Exion. Whip is now sitting beside me. Start paying closer attention, Nina.
I'm trying, I promise.
I'm not a fan of saying brackets myself. I like saying braces. So, and curly braces to be more specific. So, but very good. For everyone that was saying bracket and brace, outstanding. We need a brace. And Marvin just said, just letting you guys know, he said, that's what I meant. Curly braces.
So
and you're
then
absolutely
nothing
right.
goes after this parentheses.
So after that parentheses. And remember, we've already said you're going to see it starting like this. I mean, that's common. But we're going to be following this convention. Next line. It just makes everything easier as far as readability goes. Okay? So very good. We have just defined a function. Defined is the key word that I'm using here. Let's jump over here and take a look at doing this for real in our sexy little Xcode. Now, watch what I'm doing. Where is my cursor at the moment, Nina? What is it above?
It's, oh God. It's above the function?
It's above what function? You good?
Oh no.
I'll give you a help.
Sorry.
It's above.
No, it's above the main function.
Yay!
Okay.
All right.
Okay.
It is above the function main. That is where I'm going to come in here and say void print hello world. Notice I'm also using a convention called camel casing. Why did I do that? I have no idea. So camel casing with our functions, notice how they start out with a lowercase letter. But as we stumble into additional words, because I mean, most of the time you're not going to have functions called add. You're going to have functions that that are generally descriptive with multiple words put together. And starting next week when we jump over into Objective-C, oh man, we're going to become verbose. And I mean crazy verbose. So, and that's when Nelson's going to get really nauseated, and we're going to have to keep the Pepto-Bismol right beside him and probably take more breaks than usual. But the thing that I want you to understand is that once we get to a new word in our description, we're going to capitalize this next word. Again, think about readability. With readability, just looking at this, I can see print hello world quickly because those capital letters H and W help my brain mentally separate it out because we can't have spaces in there. Okay? And this is using the standard convention for C. I just wanted to say that real quick. You will see other conventions as well. And we're going to be talking about some other stuff convention-wise as we get over into Objective-C. But right now, this is how I'm going to be doing everything when we're coding in C. All right, so now, do I have any problems with this program? This is all we have written out over on the whiteboard. Is this good? Am I legit? Have I done everything that I said I needed to do?
Hold on.
And Thomas said no. I got another no. I don't know. I'm coming here, and if I run it, it built it successfully. Didn't give me any output, but I have defined a function. I've got a better one for you. I have defined and declared the function. Jonathan's right. I've done everything right. I haven't invoked it yet.
Okay.
I haven't called upon it to do something. You can think of this if we jump back to the Nina washing dishes. I have taught Nina how to wash dishes. So she knows how to do it now. She's like, all right, yeah, well, this really sucks. But then she went and sat down, started watching TV. She didn't actually do anything. She just, in fact, we didn't even stand in the kitchen when we did it. I just explained it to her. So she knows how to perform the task now. But until somebody calls upon her to do it, and that could even be herself telling herself to go wash dishes. But until that functionality is invoked, it's not being used. So to actually invoke print hello world, I can just come down here, and it's just a matter of saying print hello world. Notice that I'm not using any parameter lists at all. So I'm not sending any arguments. I have no parameters being defined up here, being declared. There's none. Remember, I said that parameter list, all your parameters are optional. Still, I have absolutely no problem with my program. You see no warnings popping up for me. Other compilers may give you warnings, but in Xcode, we're totally cool. I can also come in here, build and run it, and we see that we have a successful build, but again, no execution, so our console is not going to open up at the moment. But by goodness, we have actually defined and declared a function, but it better do something. If we don't go in here and give it any statements, the function is really worthless. It's just a waste. So let's go ahead and put some code in here. What kind of code do you think I'm going to put in here? Nina, what do you think I'm going to put?
Oh. Is that, oh God.
Well, what is the name of this function?
Hello world. Okay, so you're going to do the printf.
Yeah, look at that.
Printf.
Printf.
And then parentheses, or whatever.
Hello world.
Hello world.
Woo, and maybe a new line, and then we can go in here and terminate it.
Terminator.
And I'm not returning anything back, so I don't have to put the keyword return there. Because after execution is finished inside this function, when we hit the end of the function, we're done. So we return back to the caller, and nothing on this line happens, and at that point we just continue on. And our continuing execution at this point is just, well, return 0. So that's it. The program ends. So now, between lines 6 and 10, I have defined a function. And since this function is above main, it has been declared to main. So main knows about it. All right, Marvin just asked, why don't we have to put return there? And that's a great question. Since the return type here is nothing,
Then you don't need a return.
it's
void.
it's optional. I mean, if I wanted to type in return here, I can. There's no error. It'll still run. But there's no reason to do that. Not in this case. There's no reason to do that because after we execute this line right here, what's the next line in this function to be executed, Marvin? What's the next line to be executed? There is no next line in the function.
Oh, not in that function.
We're at the end of the function. And just always remember, when a function ends, when all of the statements within a function have been executed, we leave it. We're done. We simply return execution back to the caller. So we return back to here and continue on. There's nothing else to do on this line. If I had called a function that was going to add two numbers and it returned a number back to me, we return back to this line and we have access to the data that it just returned back. And so we could finish the line out. That'll make more sense shortly when we start getting into showing how to send data around. But in this case, just remember, this is real simple. If the function doesn't return anything, if it returns void, then we don't need to specify anything to be returned. It hits the end of the function, and the compiler knows when it wrote or translated all of your high-level code over to machine language, it knows that once we're done, execution will simply go back to where we called it from or invoked it from. So Marvin asked, if something is in the parameters section, are you not returning void then? That's where, and we're going to be talking about that in just a minute when we get into the different types of parameters. But if we may take in information, so when we say take in information, we're talking about
scanf.
We're talking about parameters and arguments. We're talking about the function has been defined with parameters, and that's in this section right here.
Okay.
We can send information to it, but that doesn't mean we have to send anything back. So as long as we have void here, we don't have to put a return in. What's really cool about return, though, is you could have a bunch of logic in here that could be written in such a way that if a certain condition happens, you want to leave the function early. So inside of a whole bunch of code in here, if you used at some point within that code return, it won't do anything else in the code. Demonstration. That's an excellent demonstration. When the program runs, we come in here to print hello world. From there,
it goes to there.
It comes up here. So execution is handed off to the first statement inside print hello world, which is return. So we return back to the caller and continue executing. And since that line is now finished, we just go to the next guy and we're done with the program. Let me go ahead and run this guy. And we see nothing because we never got to the printf. So let me take out my return and run it now. Now we get our console window and you can see hello world. Okay. And I like what Thomas wrote over. I just looked over in BuzzNet. I like what Thomas wrote over there for the record. Let me jump over here for the couple of you guys that are not in BuzzNet. Shame, shame. You should always be in BuzzNet. But like, how you like this, TF? You said something that I'm going to use in class. I like it. He's got what do I give back? Then he's got function name. I'm just going to say fun name. Open parentheses. And then what do I expect you to send me? I'll just say what do I get? So there's an awesome way. I like that. There's an awesome way of looking at syntax from a different perspective. So what do I give back and what am I expecting to receive? Two different things completely. And that will, at this point, I mean, I can go ahead and say that that'll take us into our description of what our, or what the different types of functions are. So types of functions. So the types of functions are functions that have no return and no parameters. And I'll just say parms. We have functions that have a return value but no parameters. We have functions that have no return but they have parameters that are expected. And then we can have functions that have both return and parameters. So you can look at this as 4 basic types of functions. So the print hello world, what kind is that? Well, it has, remember, void represents nothing. So we have no return. And what's our parameter list look like?
We have no parameters.
That's right. So that's the type of function this is. No return, no parameter list. If we were to take something in but no return, then it would be a return with, or excuse me, no return with parameters. Exactly. So is this making sense? So if I wanted to jump back over here into Xcode, just looking at that.
I think so.
Okay. Okay, Nina said I think so.
I think so, yes.
So I want for you guys to, well, actually before I even do this, let me talk about one more thing. We saw that we use this guy by calling it. And here we are calling it.
I have a dumb question.
No, there's no dumb questions.
Okay, why did you put the void before the main? Like,
the void before the main?
Yeah.
Or are you talking about the definition of the whole function?
Oh, okay, so you're defining.
I'm defining it and I'm declaring it here.
Okay, so that has to go first, and then.
So no, it's a wonderful question. And Jonathan just says you have to define it before you use it.
Okay.
And that's a double-edged thing that he just said there. Depends on who you talk to, because you always have to. It has to be defined, but it doesn't have to be defined before you use it, as long as you declare it before you use it.
Okay.
Always has to be defined somewhere, but it doesn't have to be defined before you use it. As far as the code being put up above, it just has to be declared. And we're going to look at declaration here in just a few minutes. And Jonathan, you're totally good. Jen said another question, because I'm going to completely pretend that the word stupid means void. The void is the declaration. The void is the declaration.
That right there is.
In this case, it's not a declaration. It is what is expected, the data type that is expected to be returned. It's telling the compiler how the compiler needs to set up information, or how it needs to set up memory that will be utilized for sending data back to the caller.
Okay.
But we're going to get a lot more specific on declarations in a few minutes, but I do want to showcase this. If I take this and cut it, because it was an absolutely wonderful question,
well,
and I move it down below, look what I have now. I actually have an error. So if we take a look at what our error is, we're going to say conflicting types, hello world. Well, that's interesting. Okay. And Exion, we did talk about we talked about it quite a bit. Why main is int, but I will mention this real quick as just a reminder. Remember. And we see here that we're returning a value, and the value is 0. But remember, the reason it's an int is for a calling program, a program that's going to run your program. If you want to return data back from your program to a calling program, like maybe you want to return an error code back. So then the calling program could be aware of different error codes, or if the program executed successfully. And then it could display that there was an error running this process. So this is an example of specifying a return type. Okay. Now, let's talk about Objective-C next week. So anyways, I just real quick pointing that out. So in this case, just until after we get back from our break and everything, we're starting out simple. By putting this guy above, we just ran out of errors and warnings. We're completely good. Because you can look at this line right here, the header of the method. You can look at this as being the declaration for the method. The compiler sees this. Even though it's defining it, this is also declaring it right here.
It's declaring and defining your function. Okay.
So down here, main knows about it. But once we take and put this down below main,
then main doesn't have
main
it.
no longer knows about it unless we declare it. So that's the important thing to understand there, okay? So, and we're going to be spending a good bit of time with that in a few minutes. So with prototypes and everything. But what I would like for you guys to do at this point, as we've now been going for a good hour of solid lecture. One moment, let me take a look at, I see Marvin had asked a question. And give me 1 second, I'm digging through real quick. And okay, the void and the int are declaring memory in the computer. Yeah, it's well, hang on, I just said, hang on. The int is declaring memory. The void is nothing, remember that. But we have to specify when information is going to be sent back. We need to specify what type of data so that the compiler, when everything gets set up, and frame stacks are created and all, it knows what kind of data to expect coming back. The void always means nothing, if that's what Nelson was about to have a freak out of. Let me finish my sentences before you freak out, okay?
Okay. Is your sentence finished?
It is now. Go ahead.
Okay. Yeah, void is the lack of a type.
Hence,
just like black
nothing.
is the lack of a color. So keep in mind that void is not a type.
No, it's nothing. Okay, now Marvin asks, for the main function, how come you are not returning string? We can't wait till break to answer. Or see, we can wait till break to answer this. This is how it has been set up. Besides,
and there is no string, as you should see.
We do have a C standard library.
Cludge.
Yeah, yes, exactly. Still just an array of characters, but I mean, that's what a string is. But yeah, we don't really have a string. Well, it depends on who you talk to. But no, we don't. But it's just how it's been set up since the very beginning, that we return. It was designed to be used as error codes that get returned.
Right, it's not designed to be used as a human-friendly thing.
So what I would like for you guys to do at this moment is for Nelson and BuzzNet to go ahead and establish a send code thing and call it first function. Nelson?
Yep.
And what I would like for you guys to do, you've seen how we can do print hello world. Make a couple of different functions and call them.
Functions are very, very, very important. Get used to making them because you will be making a lot of them.
And check this out. What if I wanted to say for int I equals 0, got to reach over here to the keyboard, and well, I is less than 5. Let's increment through I, and then let's come inside here. Actually, let's just cut it from here. And let's paste it in here. Nina, when I run my little program right now, what's it going to do? What's it going to do?
You haven't... Oh, goodness, wait. I'm thinking.
What's it going to do, Mr. Marvin? Help her out. Ashley's so slow.
Have you not declared what I is yet?
Yeah, but remember, the way a for loop works, the very first expression is our initializer. So we've declared it here.
Okay.
So we have int I, 0. So we now have an I that we can make use of in here.
Oh, okay. So, well, then it would print hello world.
It's going to print hello world. How many times is it going to print hello world? Ashley said 4. We've got, okay, so MMO Dust said 5.
Wait. 0,
And
then
this
1,
is
then 2,
this is
then
an
3,
awesome,
the fifth,
awesome.
5
All right,
times.
Nina says 5 times. So let me go ahead and run this. And then 1, 2, 3, 4, 5. Be careful, guys. Do what, Nelson?
Oh, sorry, never mind.
We started out at 0,
Yeah, 0.
and we're using less than. Okay, not less than or equal to. So as soon as it became 5, so 0 counted as one of the times we printed it out. And Ashley said 6, but that was an accident. So this is an area that you guys will have to be really careful in, because the off by 1 error is a very common problem for people when they're not thinking their logic through as, am I going to do 5 times or am I going to do 4 times? But we'll get more into that a little bit later. Ashley said I actually had to count on my fingers.
I did too, Ashley. Don't feel bad.
Nice.
I counted on my fingers.
Now, so I ran this, and notice I didn't have to retype hello world. I just kept calling that
Right,
function.
because you already have it up there.
Exactly. So at least 2 functions, write a couple functions, simple ones, call them, make sure your code runs, and then submit the example in the send code or through the send code button in BuzzNet. And then also feel free to take a break. So we'll give a few minutes, and then we'll come back. Is void 0 and int 1? No, sir. 0 is an actual type. Void is...
0 is a value.
Or a value. My bad, yeah. But it is... void is nothing.
Void doesn't have a value.
Yeah, void has no value. And saying void is 0 would be saying that void had a value.
Oh, my goodness.
Okay, so what I'm going to do is go ahead and pause the recording at this point to give everybody an opportunity to put together some real quick examples and submit them, and also take a break. So here we go, pausing. And welcome back, everyone. So let's go ahead and jump over to Nelson's screen, and we'll take a look at some of these submissions that we've got in.
There we go. Now you should be seeing the default background.
Yes, we're seeing the default background.
Alrighty.
We see void, somebody said.
Can somebody please explain to me in logical reasoning why the maximize button on Mac OS doesn't actually maximize the window that you clicked it on? Hold on. At least we can finally drag from any edge. Like, seriously, dragging from any edge was introduced in a recent Mac OS version. Okay, so you just wanted me to go through these?
Yeah, just go through them, take a look at what people have submitted, and see if you have anything that you want to point out. MMO Dust, I'm not a fan of how, from a readability point of view, I'm not a real big fan of your if statement down there. That's just me. It's completely fine like that.
Yeah.
But I am not a fan of that.
Yeah, me neither. You failed.
Oh, no.
So talk your way through it, Mr. Pencil Shavings. Don't make me do it all, Nelson.
Yeah, it looks good. For the sake of the exercise, it looks good. Yes, but for if this were like production code, I would.
Can't go ahead.
Well, it's just that there's a lot of functions here. But that was the point of the exercise, so I guess I can't knock them off.
Yeah, but what? Good job, sir.
Well,
Good job.
Okay.
He did the exercise. He did exactly what I'm looking for.
It is it's very good. It's
What?
semantically correct. Except for there's 3 new lines up here. Should probably only be 1 or 2. All right, Exxon, nice ASCII art. And what is going on here? Where's main? this is another thing. Why does it scroll backwards even when you're using a mouse? Yeah, looks good. I'm not sure what the ASCII. Oh, so it's this that it's okay. That's the output. Okay, yeah, looks good. I like it.
Ashley's saying.
Except for some reason, there's a scanf down there. Probably to keep the console window open. Scion. Yeah, that looks good. The one thing I would probably do different is I'd probably initialize order number to the invocation of display menu. But that's a stylistic thing. Obviously, this is more than adequate for the submission.
And Evan, real quick, answered your question with Nelson. Reverse scrolling must still be enabled in system preferences.
Yeah.
System preferences.
Yeah, I'll have to, like with that, on the trackpad, I don't mind so much, but on the mouse, it really is weird. Jen, yes, this looks good. The only thing I would suggest is, again, this is going to be formatting. These lines, now this could be because of formatting differences between your IDE and the pre-processing that this little thing that I wrote does to tabs and spaces. So, but I would suggest if these are not lined up in your program to make them lined up.
Hey, Nelson. Do not click. Do not. I was trying to time it to right as the mouse went over towards Saturn 226. Do not click on hers. Don't click. Don't.
No.
Do not click.
You're tempting me.
I know, but you can't. People can see, and you cannot click.
She says it's homework. It's not for this today.
Oh, darn it. Why'd you have to say that? Now he's not going to be concerned. I just wanted Nelson kind of freaking out with.
I was thinking, like, oh, what could she have possibly said that could offend Jason? Jeez.
Nothing offends.
But anyway.
Continue. Sorry.
So for stylist, obviously you grasp the concept of everything that we're trying to do in this exercise. So good job on that. It's just the stylistic things that I would suggest. Again, make these line up if they're not. Maybe they are on your screen, they're just not because of the pre-processing my stuff does. I would not have an extra blank line right here on main. I would tighten that up a little bit. The line between return 0 and print selection is good, though. I typically do stuff like that. Then also, I don't know why there are 2 lines right here. I would probably knock that down to just 1.
Yeah.
Wait a second.
Right, so
can I click on?
Nope.
Which one do I?
Yep.
Neither?
Yeah.
That's right. Neither. Ding.
Okay, we're ignoring Saturn.
Yes.
Oh, you're using global variables.
Oh, yeah, he's using global variable. I was like, what am I looking at for a second? Because I didn't even look up here. What Jason said, basically. And the stylistic things also apply to what I told Jen. I wouldn't have these 2 blank lines. I probably wouldn't even have this blank line, and I definitely wouldn't have this blank line, nor would I have... Well, maybe it's okay because you're consistently putting in 2 blank lines between functions.
Not only that, but of course this would be a compiler error because where is main?
Main.
Oh. Wow.
Jeez, Nelson.
Yeah, no main.
I just assumed that this was main because
your reading skills are epic. I just assumed.
No, my mind just put main in there. I mean, I'm so used to looking at code that sometimes my mind actually prints out code in my head that isn't there, and that's what happened. Yes, you need a main. But yeah, stylistic things. And people might be saying, oh, you're talking about new lines and as far as style stuff. That really does matter because being able to quickly read through code is entirely predicated on how you style your code. And the most important thing is consistency. Notice how I'm, for example, I just looked at these 2. This one has a space between the parentheses and this one doesn't. That stuff is really going to make the code less easy to read. In this case, I kind of glossed over it because they're both empty, but if they had parameters in it, it would irritate me.
So, all right, hang on real quick. Well, we did have a question about why are global variables bad. Do you want to give that a shot, Nelson?
Well, there's a lot of reasons. I mean, they're just really bad. Global variables, to put it as succinct as I can, because keep in mind that everybody's saying global variables are bad, and everybody will say that. If you talk to any developer who's been working, actually writing code for many years, they'll say global variables are bad. Some may say, oh, for performance reasons, we'll do this, and maybe they're justified. Maybe they're probably not, though. To put it as succinctly as possible, global variables introduce mutable state to the entirety of your program. So to break down that statement, global variables that are accessible by everybody, can be altered by everybody. And then you easily, it does not, obviously in this case, because all the code fits in one screen, it's not going to be that big of a deal. But if you had like a 500-line main file or multiple files and you have global variables, you are going to get confused very, very quickly because you will lose track of where the state is being changed. The next reason why global variables are bad is because they're basically like a singleton. And I know that's a design pattern-y thing, but just think about the word singleton. There's only ever one age in human years variable in this entire program. What if you wanted to calculate this multiple times? Now, you could reuse these global variables, but then you introduce the risk of getting very confused. And if this were a more complicated example, it could mean that calculating these things multiple times could overlap with each other, then you get lots of confusion. The next thing is semantics. What you have here is void age and dog years doesn't really speak doesn't speak very much at all, as it doesn't describe the data that it wants. Functions should be encapsulated in so much as the parameters should really be the only data that those functions are allowed to use. Because if the parameters are the only data that the function's allowed to use, then the function's going to have to explicitly state what parameters it wants. And that aids in the readability of your code substantially, because now you're able to look at a simple function signature. I don't know if Jason used that. I can't remember if Jason used that word.
Nope, I didn't. I was trying to avoid fancy words for the time being as we're just getting into some of this stuff.
Okay, and what I mean by signature is the signature is the return type plus the name plus the parameter list. And the function signature should really give a very good indication as to A, what the function needs to work, B, what the function is going to do, and C, what kind of thing it's going to give back. So this doesn't really say what it's going to do because it has no verb in it. This is a noun, age and dog years. There is no verb in this statement, so you don't really know what it's going to do. Printf is a better example because print is a verb. You know what this function is going to do. The next thing is you need to know what the function is going to give back to you. In this case, this is good because you say void. That tells the programmer this function is not going to give you anything back. Now, the next bit is the problem. Reading through this function signature, I do not know what data that this is going to be printing or what it's going to be doing with anything. I can't easily see that this function is going to be accepting any data, and the readability of the function then just suffers because of that. So just keep in mind, global variables, they introduce bugs in your program. They will always inevitably introduce bugs in your program because you will lose track of who's responsible for editing what. You'll set a global variable, then some function 5 files away is going to break. And I guarantee you that's going to happen. It always happens.
Yep.
Next thing is it breaks the readability of your functions because you no longer parameters are useful not in just what they're useful for, but there's also a meta usefulness of parameters, and that is it helps describe what the function is, what it does, increases the readability, and gives programmers more confidence in knowing what is going to happen when they invoke that function. And then finally, it also breaks encapsulation because now this function is taking its dirty little fingers and reaching outside of itself to grab at something that it shouldn't have any business grabbing.
Very good. I wouldn't mind, Nelson, since you said it, let's go ahead and spend 1 second on it. Let's emphasize with naming the verb and the noun concepts.
Yeah, function should always be a verb. They should always have a verb in them. Your function, it's like Tim Minchin says, a verb is a doing thing. Your functions do things, and you really need to express that in the name of your function. You need to know what the function does. In this case, we know printf prints. Scanf, now I don't really like the name of this function very much, but it does say scanf, and if you know what it means by scan, then you'll know what it does. It's, again, a verb. Nouns should be used for variable names. Your variable names should never really ever be verbs. I don't think I can think of a case where a variable name would be a verb. Variable names should always be nouns. So in this case, you got it right here, where age in human years, age in dog years, those are good variable names, and they follow that rule as in they are nouns.
Very good. Now, real quick, let's go ahead and take a look at TFs real quick.
If he got this wrong, I would fly over. Ooh, seriously, TF? Seriously? Mixing brace styles? Did you throw that in just to bug me? See, I don't particularly like this, but I wouldn't mind if you were consistent about it. Next off, why are there 2 new lines right here? There should really only be 1. Unless you're consistent about putting 2 new lines between the return statement and other things, in which case that'd be fine. Again, formatting, everybody has their preferences. I have my preferences. But the most important thing is consistency. You have to be consistent with whatever style you want to use. And being consistent with the style I don't like is still more readable to me than being inconsistent with your formatting.
And we did have a question over in the questions panel from Marvin asking if you can go back to Jonathan's code, Scion West's. Okay. Mm-hmm. So if you want to, for Marvin's sake, if you want to just trace through the logic to explain what's happening there.
Sure. The first thing that you should read when presented a file like this is main. That's really the first thing. Now, there is a bunch of code up here that is defined that might kind of clutter your vision, but your eye should instinctively go to main if you want to know what the program is doing. That's because this code in and of itself does not actually execute anything. It defines functions, but doesn't actually execute them. Functions have to be executed for them to run. So just ignore all this for now and focus on main. So let's look at main and trace through the execution of this program. What we see here is the first thing that we do is we print out a welcome to Jonathan's Burgers message. So that should be pretty straightforward. The next thing we do is we invoke a function. We know this is a function invocation because it's an identifier followed by parentheses, followed by a semi. With the exception of a few keywords in the C language, anytime you see this pattern, you know you are invoking a function. So what's the first step when you're trying to trace through code when you see a function invocation? Well, that first step is to actually find the function definition to know what the function is going to do. And in that case, I can go ahead and quickly scan through this code because it is formatted very nicely. I can quickly scan through the code and see, okay, order dinner goes up here. So now I'm in order dinner. The first thing it does is it declares and initializes the order number integer local variable. And then it immediately turns around and assigns the result of invoking display menu to that variable. Now, again, this is another thing. When you see an identifier followed by parentheses, you know you're invoking a function. Most likely, again, there are a few exceptions to that. In this case, we know we're invoking a function display menu. I don't know what, as I'm reading through this code, I don't know what display menu does yet. So what I'm going to do is I'm just going to scan through the code again and find the function definition of display menu, in which case that's just up here. So, yeah, we started on main, we printed out a message, we jumped into order dinner. Order dinner invoked display menu. And display menu prints some stuff out to the screen. So those are all fairly straightforward printfs. Then it initializes number to 0. I want to point out really quickly, I didn't notice this at first because I don't write much C, honestly, and this would be a valid Objective-C, but in C, like straight up standard C, you have to declare your variables at the top of the function. So this would be a syntax error if you were to compile this in Visual Studio, for example. But next up, he declares and initializes a variable type of integer called number and sets it to 0. Then he enters a do-while loop, which is a very appropriate loop in this case because he wants to first prompt the user for something, accept user input, then only exit the loop if that input is valid based off the rules of the program. What are the rules of this program? Well, the rules of the program state that the number has to be between 1 and 3. So while the number is not between 1 and 3, we'll continue to loop through, redisplay the prompt, and re-ask the user for their input. Finally, once we get out of this loop, the only way to get out of this loop, if we look at the loop expression right here, is if the number is between 1 and 3. And then we return that value back to whoever invoked display menu. So now we unwind the stack. We pop off display menu, and we return the value of whatever's in number to whoever called it. So the person who called display menu is order dinner. And order dinner is going to take the value of display menu, the value of invoking display menu, which is ultimately going to be this number variable, and puts it in the order number local variable. So notice how he's not using a global. He could have used a global here, but instead he didn't use a global for representing the user input of what item they wanted, and instead he just used functions to their fullest extent to make this code a lot more readable. So right here we enter an if-else-if block. It's pretty standard stuff. If the order number is 1, print pork chops. If the number is 2, print cheeseburger. If the number is 3, print steak. Now in a program, let's say this was an actual more fleshed out program, I just want to give this context to people who might be following along. Right here he might do something like also deduct or set another variable that indicates how much this order is going to cost the user, for example. Then finally, once he exits this if-else-if block, he prints out coming right up, and then the function returns. Now, there is no explicit return statement within this function, but we know it returns because it reached the end of the function without, well, returning, so it must return. Finally, that brings us back down to main. The third line of main, order dinner, or the second line of main, order dinner. And then we enter the third line of main, which is another printf, thank you, come again. And then we exit the program. And there's no return statement on main. So that's another thing that you should probably add in as a return 0.
I like what TF said. Coming right up, Viagra's slogan. Very nice. Yeah, no, that was excellent. And it was a nice walkthrough. And if you're looking at this, Marvin, and having a hard time understanding what's going on, don't stress it. Because what Jonathan was doing there is he was demonstrating putting everything we've talked about together in an application. So, and we're going to get to that point. Let's go ahead and jump back over to my screen. Let's see, that would be this one over here.
Yeah, sorry also for being hard on people about formatting. It's something that I find very, 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 very important. And I don't want to discourage anybody if they don't have an eye for it, but that's an eye for formatting is something you will invariably develop as you start writing code.
And as you're beat enough, you'll finally just give in and start formatting it right. So just continue beating them, Nelson.
Do right.
Yeah, man. Okay, so the next thing I want to talk about before we start getting into our parameters is I want to spend just a second and talk about function prototypes. So let's jump over here and let's hunt for some room. Function prototypes. Remember how we said, of course, you've got to have your function's got to be defined. Defining is extremely important. I mean, if a function's not defined, doesn't exist. There's no code, nothing. But it has to, more importantly, it's funny, you say more importantly, but it has to be defined or it won't work. But it has to be declared for it to be used. So that's the key thing here. For function prototypes, give us a way of declaring our function. And we have already seen that. Remember this? The include preprocessor directive, and we brought in the standard input-output header file. That header file contained a bunch of prototypes in it for methods that have, functions that have already been compiled into machine code waiting to be linked in with our application when we build it. So if I jump back over here real quick, we saw in Visual Studio, we see in Xcode that if we had taken print hello world and moved it to another location within the program, we've got a problem. Before main can take advantage of print hello world needs to be declared to main. Print hello world, this guy right here, he could exist in a whole nother file. I mean, obviously, printf and scanf, they're not defined inside of here. Oh, by the way, and Jonathan says, has too many random blank lines. Oh, you'll constantly see a lot of those. And that is simply to help making it easier for students to dissect the part that I'm working on at a given time. Yeah, and I'm going to just stick with that excuse. Well, you may be joshing, but I'm going to stay with it. So here's how we do a prototype. Very, very simple. So I need to declare the print hello world. Void print hello world open. That's not open. Open, close, terminator.
Oh.
Build failed. Why do we have a build failed? What am I doing retarded here that I'm not seeing? Nelson.
Yo.
What am I printing wrong here?
Why did it?
Oh, that's impressive.
That is very impressive. Because it is actually...
Oh, ha, 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 ha.
What?
Or is my head off in another language right now?
No. Your syntax is fine. This is a good demonstration. Though.
Yeah, no, go ahead. Because
continuing to make Jason sweat for a few minutes.
No, go ahead. I don't even want to stop to think about it.
You have a spelling error on line 6. The most
I
common
almost
mistake ever.
almost didn't see that at all. Yeah, and that is so true.
I was in here looking like, okay, I have the same thing on my screen.
Yes, and I did that on purpose, as you guys can see. Spelling, make sure. No, seriously, I did not see that. And all of a sudden, when I had that error, it's like, excuse me, that's prototyped out properly. But
that's like the most unreadable error ever.
Yep, and Nelson is yeah. I just happened to see Jonathan's redneck spelling for hello. Exactly, that's how I'm used to spelling it. But as Thomas just said over in BuzzNet, that is a sneaky error. It really is, because I wasn't focusing on the actual letters that I used to spell out print hello world. I was focusing on the big picture. And the big picture was I had my function declared. That's the key thing that I'm trying to emphasize here. I had it declared before we used it. So now down here, we're using it. So all is good. So that is a really good thing. I'm glad it happened. It's a really good thing to point out, and that is when you start getting these weird errors, that you have a hard time seeing, and you look at your code and you think to yourself, wait a minute, the code, and there wasn't a problem, as Thomas just said, there wasn't a problem with line 6 at all. The problem was coming from elsewhere. Make sure you look carefully at spelling. Make sure you look carefully at your use of any type of symbol, be it terminators, open and closing parentheses, etc. Very, very important. Okay, so yes. Get your mic closer so they can hear.
Why do you use the terminator now when you didn't before?
Okay, it's a good question. Why am I using a terminator now? This is something different. This is not a definition. If we did not have a terminator here, we would be trying to define, actually give the meat, give the whole template, if you will, for the function, define it. But that's not what we're doing here. We are telling the compiler that we have a function that exists somewhere that we will be able to see in this file called print hello world, and it matches this signature. It has no return type, or the return type is void, and it has no parameters that it takes.
Okay.
So we're telling the compiler, hey, trust us, it's there. And so the compiler's like, okay, well, then we can just go ahead and start working our way forward. Without this guy up here, again, as we work our way forward, the compiler doesn't know that print hello world exists when we use it here because it had not already been defined.
Okay.
So as Ashley just said, I love getting the students involved with their descriptions. She has a good one. Her description was, dear compiler, I promise that there is a function called print hello world somewhere. Believe it. And that is correct. Now, I do want to point this out. We're not going to start getting into, we're not going to focus on this at the moment, but I do want to point out that these prototypes generally, and Nelson, no sighing over there. As a matter of fact, Nelson, go ahead and hit mute just so that the lagged air sound goes away. Awesome. I'm going to cut this prototype out right here, come back over here to Basic Program, right-click on it, and I'm going to say Create a New File. And then inside here, from OS X down up under C and C++, I'm going to make a header file. Now, of course, you could just do a blank file and, just call it the header file, but, well, you'll see. So I'm going to say make a header file, and then what do I want this header file to be? Generally, it's going to go right there with your C files, because remember, main.c, that's our C file, our source code file. And for those of you that are looking at how I got to that, because I just happened to look over at Nina, who's trying to figure it out, I right-clicked on Basic Program.
Okay, that's the part I missed. Then
and said new file. And now over here,
okay.
I'm going to put in the name for my header file, and this will be a file that is .h. And so over here, now your header files are usually the same name as your source file. And in this case, I'm just going to call this one my header, since we're not focusing on making header files right now. So again, I'm saving this as my header, and it's going to be put into the basic program area right here, this folder. So let's go ahead and create it. Now, by using the template that was there for us, we already have some code that appears. And we all know that these guys are our preprocessor directives. And these, now, of course, we don't know what, if in def, if what? We're checking to see if it's defined or not defined. And what I'm referring to is going to be, well, no, I don't even want to get into that. In fact, I'm just going to skip it all. Let's just forget that even exists, because I don't want to start talking about cyclic includes and stuff. Let me just do this. Just another file altogether. So we've got our prototype in the header. So the prototype is in the header. I'll save that. Let's go ahead and jump back over here. And now let's just rebuild. And what have I typed wrong now? Nothing. But are we telling the program, this source file, that it needs to be aware of that header file? Anyone? No, we have to, as Jonathan just said, we have to include it. And now hopefully this will make the include standard IOH and the standard bool H make sense. Notice these are header files too. So since I'm not including my header.h, again, this file has no clue. I mean, it's not like it's going to go out there and take a look at every single header file on your computer. It needs to be told to include it. So what I'm going to do is come in here and say pound include, but I'm going to do something a bit different. If you recall, before I used the less than and greater than, and that's just basically saying that we're using system installed header files. In this case, we're using our own custom header file. I'm going to come in here and just do
Quotes.
double quotes. So I'm just going to come in here and I'm going to say, what's the name of it? My header. And look at that. It's already picked it up for me, and I can finish it off. Now, all of the errors went away. It says there are no issues if you take a look up here. And if I do a command build run, we get execution just fine. So header files are very important for, we don't put implementation in header files. It's very important for putting our prototypes. So once again, our prototype was put over in the header file. And again, when we get down to, so these are special little love notes to the compiler before compilation begins. In this case here, we're telling the compiler, hey, what's up, Bob? Do me a favor. Take the myheader.h file, and yeah, man, you see how these are in double quotes? Yeah, you're going to find it right there in the same folder as this source file right here. Yeah, if you don't mind, include what's in there for me. And Bob's like, hey, man, no problem. So Bob takes what's in here. It's a prototype. All he does is takes it, and he includes it right there. Just includes it in the C file. Why is this important? In this case, it's a very simple demo program. So what I really need to have a header file that has my prototype, my single prototype exist over in that file? New.
Okay.
If I had a real world application that has a lot of functions, yeah, you're going to want to start putting all of the prototypes over into header files to keep things organized nicely, to keep your code here in the actual implementation file, in our source file, from getting cluttered up. I mean, what if we had 100 functions in here? Do we really want to have 100? Well, hopefully you'd consider breaking it up into multiple files, but let's pretend you don't want to do that. Do I really want to have 100 different prototypes that I have to scroll through just to start getting down to the definition of my functions? No. Am I going to ask you guys to start? Some people sadly say yes. Again, Jonathan, yeah, you're right. We get back into that war on exactly. It's messy. In this case, you want to keep things small, tight, and to the point. And using header files will allow us to offload all of those function prototypes into another file that we can tell the compiler to please include for us, so that we can keep our source file focused on actual logic, actual code, implementation. Okay? So I just wanted to point that out to you guys, and we're going to be having a little bit more fun with our header files when we start getting into Objective-C. But I just wanted you to at least see where these header files that we're using above, what they're really doing. But again, these are special system header files that are available for us from the standard C library. And then by using this less than and greater than symbols, the compiler knows exactly where those guys are going to be, because those are not going to be in every one of your programs. It's not like you copy all of these header files over into your program that you're working on, into that folder. But your header file, like here, it does reside in the same place. And so that's why we have the difference using the quotes. But back over here to the prototype. The prototype is nothing more than putting the...
A promise.
Do what now? I didn't hear you.
A promise.
Yeah, it's just putting the promise. I got you. It's just putting the promise to the compiler that that definition for that function does exist somewhere. So, and looking over at Mr. Wizzykin, yeah, we're making that function. So what I want you, and that function may reside in other C files. Doesn't have to reside right here. So what I want you guys to do, I'm going to pause for a minute, but go back to your little program you wrote, and if you already deleted it, no worries. You do not have to make a header file, okay? If you want to practice with that, sure. But all I want you to do is make a couple functions, make them after the main function, and then put prototypes at the top. Remember, the prototypes end with a terminator. So it's going to look just like the actual declaration start. It's going to look just like the header of the function, except with a terminator on the end. So I'll go ahead and then send those in. Nelson, could you create a new section for our students that's called function prototypes? And then you guys can submit it to that, and I'll go ahead and pause the video. Thanks, guys. Welcome back, ladies and gentlemen. So we're going to jump over real quick to Nelson's screen as he is going through some of the submissions. So here we go over to presenter, Mr. Nelly LeKay. There you go, sir.
Okay, see my right screen?
Yep, we sure can, sir.
Okay, Wizzykin has a function called pass by reference, which takes in a pointer. I just want to nitpick this really fast.
Yeah, go ahead.
I wouldn't say pass by reference here because this isn't an actual reference. This is a pointer. C doesn't have references.
He knows that.
Now C++ does.
He could have said simulated pass by reference. Would have been a good name. But
okay, I just wanted to nitpick that. Well, but yes, you did. You did pass.
Look at you go. Very fancy. I like it, sir. That's awesome. Did he show Jonathan up with wait, where is Jonathan's? Oh, there's Jonathan's. Are you still on Jen's, or are we just looking through?
No, I'm just looking through.
I'm just so confused with your highlighting. Okay, so again, just take a look at each of these things as Nelson's going through it. The big thing that, and it looks fantastic, everyone needed to make sure that their prototypes go outside of their functions up at the top. Getting a warning. Oh, hang on. What do we have here?
I figured out I would throw it up anyway. Don't throw up code.
What?
The warning is probably from that line right there.
Maybe, yeah. But yeah, it all looks good. But right here, keep in mind that standard C, you can't declare private local variables anywhere other than the beginning of a block.
Right, and that's why I'm assuming that. So, yeah, make sure that those are higher up.
Excuse me.
Okay.
Right.
So is that everything else, or?
Yeah. Well, and also I'd probably return this value instead of just grabbing it. I would probably. Yeah,
I would absolutely.
Oh, here's your warning. No, never mind. Sorry, ignore me. What are you saying?
Well, first of all, I was just going to say I would absolutely return it for sure, for the simple fact that it is it's returning an int type. And go ahead with the. And what else were you going to say?
No, nothing. I misread the code really fast. I would also delineate arguments with spaces. I typically find that's easier to read. And right here, you're printing your printf right here, age in human years. You're actually printing out the address of this variable. But that'll make more sense. You might be getting confused about when you need the ampersand, when you don't need the ampersand, and that will make a whole lot more sense once we go over pointers. In this particular case, this code will compile, and it will print something out, but it's going to print out the address in memory of that variable.
And we're gonna spend lots of time with that stuff coming up next week, and I still really think that I want to get a workshop scheduled for those of you that feel like a little pointer abuse for a couple of hours. We'll make it a good time. We'll bring some popcorn and a bunch of salt, and you guys know exactly what I'm saying. All right, so
we'll leave that at home.
Thank you guys very much for the submissions. It is greatly appreciated. And I really like how we're doing this, where Nelson's also giving feedback about the formatting and how the code's being structured by some of you guys. So that's really nice. I'm not answering that one, Tia. So let's go ahead and jump back over here to my screen real quick. Thank you very much, Nelson. Okay, so a quick recap. We've looked at what functions are. We've talked about, as a matter of fact, I'm going to jump over here. We talked about what functions are. Wow, that's scary. How to define them, and we discussed basic syntax. We talked about they have to be declared before we can use them. And we saw that we can declare functions with function prototypes. Isn't that awesome? It's such a fancy word, right? Function prototype. Wow, you sound like you know a lot of cool stuff. No, it's just the function header, basically, with a terminator at the end. Congratulations. We now know that to pass execution to a function, we must call it or invoke it. We know that once it's done executing that function, that execution returns back and continues from the caller. We also know that in C, we saw that we have pass by value as the only way of sending our information. We'll get into pointers and all later. We don't have pass by reference, and that only goes out for those of you that know what that means.
And it sends a copy.
So it just sends, it makes a copy.
Makes a copy.
Makes a copy. And we're actually going to see that in just a few minutes when I draw a stack example. And then the last thing is going to be stack. But before we get into the stack, if we come back down here to our basic syntax, the one thing that we haven't really done at this point is talked about the parameter list and the return type. And if I was a typical instructor, I would say that we've already given enough examples and you should be able to figure out exactly how to use your parameter list because you've seen examples. But I need to make sure it's very clear. And you guys know I'm very verbose, so please forgive me. So let's talk about our parameter list so that everybody understands what's going on, and then we're going to look at the stack to drive home the point. So if I was to have an int main no parameter function that had inside int, let's call it x equals 5, terminate, and then let's say int y equals, let's do 6, terminate, and then I'm going to say int total. Yeah, and bear with me, I'm making some stuff up real quick. And we'll initialize it to 0. And I'm going to tell main that I promise you, through a function prototype, that there will be a function defined that returns an integer that is called add. I'm just going to call it add, a little more verbose. Add numbers might be nice. And it's going to have a parameter type of int, comma, int y. Terminator. Now, for those of you fancy people that know with prototypes you don't have to include types and all that stuff, good for you. I'm not going to share that with everyone else to confuse them. Moving right along.
You mean
I mean names, identifiers, correct. They just have to include types. So we could say int, comma, int, but don't worry about that. We're going to do it like this. So with that, I can now say, and if you don't know what I was talking about, pretend you didn't even hear me talk. I did not flap my lips around.
I didn't hear anything.
Nope. Total equals add, and I'm going to send what's in X, and I'm going to send what's in Y. And then we'll have a little return party where we return 0 back to whoever the heck called this amazing application. So at this point, everything's totally kosher because I promised the compiler through this function prototype of add that there will be a function defined. So I can put it wherever I want. So let's go down here and let's actually define. So I'm trying to make sure you guys get the terminology down. I'm going to define the function now. So it returns an integer. It's going to be called add. And it is going to take in an integer, comma, it'll take in another integer, and now let's jump down into here, and I got to take up all this space.
Okay.
And I'm going to say return, I'm just going to keep this simple, x plus y. Instead of putting it in another variable, which is what I was going to do, but I don't want to have to like slide back and forth. Okay? So, we now have a function that has a parameter list. So check out how I say this. We now have a function that is expecting arguments to be sent to it. Remember what I said earlier? Arguments, that's data. So isn't it completely kosher to say we now have a function that's expecting data to be passed to it? And so we can replace that word data with arguments. So this again is the parameter list. And we already know that these two variables up here, variables exist to hold data. These guys are holding data. So we know that when the program starts, we get a little X in memory, and it gets a 5 put in it, and when we execute the next line, we get a Y in memory, we get a 6 put in it, we get to the next line, we execute it, we get a total in memory, and it gets initialized to a 0. And then we get down here to the next program. We have an assignment operator. So first thing that's going to happen is our right side is going to evaluate first. Now remember what I said about function calls. When a function is done, what happens? We return back to the calling function. We return back to that line. So this is the line we're currently on with execution. Function call. So now we call the add function. This is so important. This add function, it has a parameter that just happened to be called X. It has another parameter that just happened to be called Y. The data is copied from these two guys up here into these parameters, 5 and 6. So I could have had completely different names. I could have had int num1 and int y1. The bottom line is this. The first argument goes into the first parameter. The second argument goes into the second parameter. If we had a third, a fourth, a fifth, so on and so forth, then we better be sending all of those arguments, and they will be going into all of those parameters. So you see how it lines up. That's really important to understand. It lines up. Also, you see down here, we have a brand new X and Y memory location that has been set up to hold information. The X and Y that exists up here, these are totally different X and Ys. That is so important to understand. You really need to grasp that. And real quick, I want to point out, I just happened to look over to my right side monitor, and it looks like some people are having trouble with audio. But at the same time, I do see people that are from Canada and all that are receiving audio just fine. So I'm going to have to blame it on GoToMeeting. So apologies, but just letting you know. So continuing on, but thank you for pointing it out just in case everyone was suffering through that. So the big thing to understand here is if we set up this parameter list, we better send data to it. We better send arguments. And the data we send better be of type. I can't go putting different types in here. Well, I mean, yeah, let's just leave it at that. I can't go putting different types in here. My types need to line up. So if I said int x float y better be a float.
Okay.
This is very, very important. So, very, very simple stuff. So let's go ahead and jump over real quick to our IDE. And let us go ahead and write int add. And you guys feel free to follow along if you'd like. So I am coming in here and I'm making a function. So int add, and we're going to take in int num1, comma, int num2. All right, so now I have put the basic syntax in place for my function. Let's go ahead and jump up to the top. Generally, this is how I do all of my function prototypes. Just Command-C to copy it, up to the top, Command-V, jump to the end, throw a terminator in there, and I know that I have no bad spelling. So let's cruise on back down here. All right, so I'll give you just a second. For those that are following along, and again, if you're new to programming, I would highly recommend following along with me right now. Very simple function with a parameter list defined.
Oh my goodness.
Giving me a warning at the moment, letting me know that the control reaches the end of a non-void function. It's letting me know we're not returning anything. So let's go ahead and tell it to return num1 plus num2, like such. All right, all warnings gone. Everything's happy.
Okay, so that.
So I'm just giving, I'm using Nina as kind of a way to gauge those that are following along.
Okay.
All right, and
Whoops.
Nina got a boo-boo. Got to have your open and closing parentheses in your prototype.
Nested parentheses.
There you go. Okay, so now that we have this in place, we have a function that we can use. Let's jump back up into main and let's use it. I'm going to go ahead and get rid of this call here just to keep things simple. As a matter of fact, I'll get rid of this guy as well. And I know we still got the header file out there. Let's jump up here into main and let's say int x equals 15. Int y equals 12. Int total equals, now I could go ahead and just make the function call right here, but let's just initialize this with a value of 0. And now let's turn around and say total equals, and I'm going to call add, and look at this. So we get this code completion that jumps in, you know, the IDE is like, hey guys, what's up, man? I'm going to help you out. We got add that you can take advantage of right here. And you can see, man, add is expecting two things to be sent to it. It's expecting two integer values. Let's put something in.
That's exactly what it sounds like, too.
Yeah.
It does. Right? So I just hit the tab button to just jump right over. It's like, okay, man, let's go ahead and put something in here. So we're going to send it X. I'm going to jump over here by hitting tab again. I'm going to send it Y. I'm going to hit tab again and put a terminator at the end. The compiler's like, man, that's all good. You got me coming in with information. What if you try to get crazy and be like, Z? I would come over here and put a Z in there. And, oh, I don't want all that in there. What? Compiler? Do not give me grief.
Okay.
It got mad at me for making fun of it. That's pretty funny. I tried to put something extra in, and the compiler came back to me, and it said, what? You have an undeclared identifier Z.
I did that on accident earlier.
We can't be sending no Z over here. We don't even know what Z is. So, oh, and I sure didn't mean to put a breakpoint there. Let's go ahead and delete that breakpoint. I'll be like, fine. I bet you know what a 5 is. Now, you can't tell me unidentified 5. No such thing as an unidentified 5. Let's click on this. Too many arguments to the function. I love this here. Basically, it's saying, look, dummy, it expected 2, but it's got 3. Also, notice how the compiler is smart enough to give you a very nice sounding method. It knows the difference between data and parameters. Too many arguments to the function. Too much data. So, nope, can't do that. So I'm just letting you know we need to go in here, make sure that we are passing the right arguments. Now, yep, we got a question. We got a question over in the questions panel. Let's see. Couldn't you put total instead of 5 if you go and tweak the prototype? Oh, we need to tweak the prototype and tweak down here as well. So the prototype and the function definition, it's a great question, Marvin. The prototype and the function definition, their signatures have to match. Signatures being return type, function name, and the parameter list. So yes, I could send total as well as a third parameter, but I would need to change, I would need to add int total up here, and I would need to also add it down here. So now let's go ahead and execute the program. All right. We got a program to execute. It did everything right. The compiler did exactly what it said. Now the compiler's off drinking a margarita because it doesn't have to do any work at the moment. But we, as the coder, did not say what to do with the data that came back from add.
Right, we need
So we can print it out.
a printf. Yeah.
So I'll say print out, and I want to come in here, and then I'm just going to say total is, and then let's go ahead and use a format specifier, and then let's put a new line in there. I'll hit tab, and then I'll come over here with a comma, and we'll use total. And I'll put some extra spaces in there just so that I can make Nelson's eye go all goofy and everything. And then we'll go ahead and build. And we got totals 27. And we can look back up here with our incredible minds and use these mathematical skills that were taught to us in the 10th grade for those of us in the United States. And for those of you that were in preschool,
In the 10th grade.
that's before kindergarten.
Oh, sweet.
You learned how to do this back then. All of you guys overseas are so lucky. So anyways, we can see that 15 plus 12 is indeed, 5 plus 2 is 7.
What?
And then 1 plus 1 is 2. Yeah, so 27. So yeah, our answer is absolutely correct.
I don't have enough toes and fingers for that.
Oh yeah, me neither. That's
I
so
was stumped.
too high. Exion is currently in the 10th grade. So if you have not yet learned about the basic addition, I do apologize.
Wait.
Now, we have Ashley with a question that says, couldn't you do int add int for the prototype up at the top also? So Ashley just put a giant statement in the question panel that said, hi, Mr. Jason. I wasn't paying attention to what you said earlier when you said that you could just use type, comma, type in the prototype, but you're not going to get, but I'm not going to get into that and explain it to people, so just ignore what I was saying. Oh, wait a minute. No, I know what you did. I know she did. She was ignoring what I was saying, so she didn't hear it.
Exactly. You said ignore.
But Saturn, yes, you could just go up there. The signature is what is important here. And what she's saying now that this has been brought out twice, it doesn't care about the names. It only cares about the types. Okay? So you can do this. So now Saturn has forced everyone in this class to understand this. And as Jonathan just said, not naming your parameters is bad practice, though, and I totally agree. Then he goes on to say that you will be pistol whipped for it if you do.
Oh, my.
I don't know about that. That all comes down to the place you work. I mean, maybe if you work for EA, that'll happen, but I don't know. I just heard. So let's go ahead and try to do some crazy stuff down.
A flaming whip.
Let's do some crazy stuff down here. Oh, my gosh. Control run. How does that work? It's almost like magic. Well, the compiler is able to see at this point that the signatures match. It's funny because the signature in this case, it's looking at num1 and num2, but it found a prototype that matches 2 parameters from the list that's going in. So just for Ashley, I did this as one extra step showing you could do this. If you ever do this with anything that you submit, I will fail you so fast. And I will put Nelson on the next bus, only because he's afraid of airplanes, and send him to say hi to you, to go out and have a drink in that Doctor Who bar, and then smack you around with a fish.
Oh, my.
We're not going to ever do this, and we're not going to do this up top. Not in a 101 class for sure. Okay? Let me keep all my naming looking pretty. Now, another thing that I want to point out real fast, and I did this on purpose. Notice how my parameters, as they're defined here in the method definition, they're not the same names as these variables up here. They're not the same names as the variables that's being passed. And I know for those of you that have been coding for any length of time, like, since yesterday, that you're like, duh, of course not. I've just seen so many people that are getting into programming get really stumped here because they know that we're passing this data over, but it's like, oh my goodness, you got completely different names down here. Isn't that going to blow everything up? That's going to be like an error, man. No, it's not. Remember, these are parameter names. This is data. You guys got to understand that. Arguments, parameters. This is just data. Watch this. 12 and 35. That's completely fine. Of course, the compiler now is going to give me a warning saying that, dude, you're not using X and Y, and that's kind of dumb. I don't think it actually says dumb, but let's check. Unused variable X. Okay, well, if I wrote a compiler and warnings, they would be much more entertaining. But so it's just letting us know these guys, unused variables is what I meant. Unused, not undefined. Me and my brain. So no big deal. Right here, the bottom line is we need to send data to our function. Because down here, we said when we defined our function that we expect data. We expect data. So we're sending data. How would I, if I wanted to, and by the way, in case you've ever heard this term before, if you've ever heard anyone say magic numbers, that's magic numbers. That's hard coding a number in. Don't do that. Oh my goodness gracious, don't ever do that. But let's say that these numbers are in here, and this is how I wanted my program to be. Now someone needs to smack me. If these names did have to match, how would I name these now? How would I name this int 12 and int 35? Can't do that. Okay, so it's not about names matching. It's about data passing. Okay, smart Alec MMO just said, yeah, you could type out 12 and 35. Okay, touche, my friend. So, and this could have been Y, and this could have been X, plus 35. See? Again, kind of crazy looking, but run the program, succeed it, 62 is an output. As long as the type is of type that's receiving the data. And Marvin just said over in the questions panel, then Y would take the place of num1. Yes, sir. That's exactly right. It is just about matching the list. The list says I'm expecting an integer and an integer. So I need to send an integer. And what do we have going on right here? We have an addition operator. So we have some math that's going to take place first. X plus 35 is going to be evaluated. That expression will be evaluated down to 15 plus 35, the answer. And then that value is of type integer. So it gets passed. And as Marvin's so pointing out, this now would be what is in num2. It's really important to line this stuff up. I mean, that's what happens. So if I jump back over to my whiteboard real fast, and make a little more room, if I had a function, my fun, that took in a float and I'll just call it, forget it, x, and an int y, and a char z, and then all the good stuff that makes up a function. It's looking for this function to be invoked or called by simply saying, my fun. By the way, we're stipulating this is void, just for anyone that's like Nelson. We're going to say that my fun, and we better send 3 things separated by commas to the function we are calling. And those 3 things that we send better be of type float, int, and a char, or car, depending on what block you were cut from in the programming world. Okay? Does that make sense? There's no way that this float would, like if at the end, instead of a char down here, if this would have been a float also, if that had been float z, that is not flat, that is a float. The force is strong with me. You shall see it that way. Of course, this means it needs to be a float. Otherwise, it'd be a problem. It's not like the compiler is going to go, we're going to send this guy over here because it's a float, and we're going to send the int down to this guy here, and we'll just send this float. It's not like that. Okay? It just simply lines up. It really is that straightforward. So that is an example of actually using a parameters list and a return type. And with that, what I want to do now is take a look at a very basic program that I'm going to write out, and then I'm going to show you guys what the stack is. And I know I saw a few minutes ago where Thomas was pretty much laughing at me, saying typical Jason, because here I am at the very beginning of a 101 class in week 2 and getting into the stack. I think it's really important. Okay, good. He wasn't laughing at me. Okay, week 2.5. Point taken, MMO Dust. You're all over it. You're going to keep me in line. I like it. So what I'm going to do is come over here and hit F7.
I think it was a play on words, Jason.
Oh.
We'll get into the stack.
Oh, like the sack. I get it. You funny, man. You so funny. That's exactly what I meant. Okay, no, just kidding. So let's go ahead and write out. Bear with me. This is where we're going to write out a very simple program. So int main. And then inside of main, I'm going to make a, an int. Let's just do what we've been doing. x5 terminator. Let's do an int y. And let's call this, let's do 6. We'll initialize it with 6. Let's do int area. We'll calculate area this time. And let's initialize it to 0. And then let's say that we're going to pretend there is a function prototype up here that is stipulating that we have a function called figure area. So let's go ahead and say area equals figure area. And again, we have a function prototype up top that already declared that that is the signature. It's going to return an integer, and it takes in 2 ints. And then a return 0. And let's end this off. And now down here, let's go ahead and do an int. And let's call this figure area. And now I have to use types. I have to say what type these are. So we're going to say int x, comma, int y. We already saw that it could be int hamburger, int pizza. Yes, I'm getting hungry. Sorry, guys. And then in here, I'm doing this for a reason. I'm going to say int area, instead of just like returning it right out, equals x multiplied by y, terminator. And then let's return area. All right. Very, very simple program. At this point, everyone should be able to look at this and at least have a general idea of what happens. Inside main, we're creating 3 different variables, and we're initializing all of them. And then we're calling on a function called figure area, and we're passing it what is currently in 5 and 6. We're passing figure area the data 5 and 6. And in execution, because remember I've said this, execution will return back to here once we're done with figure area. So it remembers this. Because remember, it needs to come back to this line because we're not done. We need to put the result of it over here. That's important. So then figure area gets that data passed into the parameter list. So X and Y become populated. We then work on it and return it. So what does this kind of look like in an actual computer? Now, Jonathan just pointed out something, and that is where I had said int area up here. I could have said int area equals figure area X and Y. I'm being very verbose here. I mean, he's pointing that only because Nelson pointed that out in his source. In this case, I'm being very verbose with everything because of the drawing I'm about to do. All right, so the stack. This is the program execution stack, also often referred to as the function stack. I'm just going to call it the stack. And the stack is, let me see if I can, oh boy, it's going to be awkward to get over here with my hands like this. Okay, that sounded bad. I know, I just realized that sounded bad. Hush up. I'm trying to decide how much space I want to use. Don't fall off my desk. My Wacom tablet almost fell off.
I wish you guys could see this. It's funny.
Yeah, I look pretty ridiculous right now. Oh yeah, almost made it. So this is our stack. Down here we have what's known as the text segment. There will be a test on this. No, I'm just kidding. I'm just going to show you a couple of things about the stack and about your program because I find it interesting. All the low-level stuff I've always thought was really cool. The next area is called the data segment. The next area, and these are 2 things you're not going to be really concerning yourself with. The next area is called the heap. You guys are going to get to know the heap really well. Not right now, but you guys are going to become good friends with the heap. Now remember, this is memory. And the up here, this is high value addresses. This is low value addresses. And what I want you to keep in mind is this memory right here, it's all virtual memory because the operating system will handle the translation between virtual memory addresses and real memory addresses, not your program. So the operating system, when you execute the program, the operating system is responsible for setting a few things up. First of all, this section of memory for you. So inside this data segment right here, this is where your program executable code and your read-only data goes. So I'm just going to say I'll just say code. And your constants, things like that. Data that cannot be read gets to go in there. Your data segment, let's go right here. Your data segment is going to contain your read-write data. Things like your global variables are going to get stuck in there. But we're not going to concern ourselves that much with that. The heap, you guys get to know the heap really well starting this coming Tuesday. The heap is it's a special area of memory. It's blocks of dynamically allocated memory. And we're going to be using this like crazy when we start getting into object orientation and we start creating classes and then we instantiate those classes. Yeah, fancy terminology we get to use next week. And then we got our object sitting out there in memory. Where's that object sitting? It's sitting in the heap. It's in the heap. How do I know it's in the heap? Because on the stack, we have an actual guy pointing to it. Now, no, Marvin, there will be no test. That was a joke.
No, and then
But-
something came up. I wonder.
But here's the important thing. So the top. Let's jump all the way to the top because it's interesting how the stack works in this case. And I do not want to edit my brush. Get out of my way. The stack actually works from top down in this particular implementation of how it all works. And I'm not going to go, for those of you that have been through computer science courses and you do understand how all of this works. As a matter of fact, I'll push it even further. And you understand how registers work with data being moved back and forth between registers and then allocated memory. And you also understand the program execution pointer and the stack pointer, all that good stuff. I'm not going to get that crazy. But what I am going to do is I'm just going to demonstrate what's going on here with memory. We start off with main. And Nina, does the main that I've drawn out right here on the blue board, whiteboard, does it have any local variables in it? Local variables. Are there any in main?
Yes.
Yes, that's right.
Yes, because
We've got X.
You define your local variable.
That's right.
In main.
That's right.
X, Y, and area.
And this time, you can thank Ashley. She quickly came in there and backed you up.
Oh, yay.
Good
Thank
job.
you, Ashley. I can't see.
So where does that memory actually go? Well, we're starting off at the top of our stack. And no, Jonathan, we're not going to talk about registers, but that would be epic. That would be so much fun. And I'm just going to keep this simple by saying we have this memory location here that's got a 5 in it. And let me adjust so I can kind of draw out some halfway decent lines. We've got a memory location here. It's got a 6 in it. And this is the actual memory location. We have area right here. It was initialized with a 0 in it. Okay, so here we are in this frame, if you will, for main. Remember how I said functions are, they're like little boxes, self-contained code that do a specific task. I drew that out for a reason. So now what I want to do is I'm going through, I'm executing, so the code's executing, and it knows that as the code's executing, this is where the variables are actually kept. So I could have just, not even drawn this. Maybe this would have been an even better way. Just put the numbers there, and over here on the side, just for our own sanity, X, Y, and area. How about that? That's kind of sexy. Now, we're executing, and we come down to this line right here, and we're going to call upon the function figure area. The reason I like introducing the stack here when I start talking about functions or methods if we're working with objects in other languages is this really helps to drive home why our local variables are local. They only exist for the function that's using them. When we call this other function, what happens is we do a thing that's called winding the stack. What winding the stack does is it puts what's called a stack frame it pushes it onto the stack. So to indicate this stack frame, I'm just going to kind of thicken this line up. This is just for your own edification, just so you can see it here. And the order in which these guys are created is a little different than what I'm showing, but I'm doing this just for, again, our beginners to make it very clear. The first thing that it's going to put on the stack is our return address. So instead of writing a crazy number there, I'm just going to put return address. That's where the heck we need to return back to. See, we're now working in a new, what's called stack frame. We're working in a new frame. We cannot see this up here. It's its own little private area. So think of it like a scratch pad that we're working with. So let me get that out because we can't see up there. I don't want anyone to get confused with that arrow a little bit later on. The next thing that it does is it's going to allocate space for us for the number of parameters that we have coming in. We have an X and a Y. These are not local variables. I want to make sure that everyone's clear on that.
No, they're your parameters.
These are parameters. But on the stack, I mean, they're going to look just like local variables because they're local. But on the stack, we just got 2 places for them. Now, through some nifty magic, what's going to happen is since we're passing X and Y, that data, whatever's an X at the moment, as we all know, it's a 5, that data gets copied into this location. The value 6 gets copied into this location. So you can see how they just got copied into these memory locations that are representing the parameters. So our parameters are now filled with data, with the arguments that have been sent. Again, we are working in a completely new stack frame. We ourselves as coders cannot write code to see outside of this. But in this stack frame being set up, the compiler knew when it made the machine code that what also needs to happen is that another spot needs to get created. That other spot was called area. And so that spot got created. Right here. And in area, so now the spot's been set up. So actually how it works is the moment you call the function, the stack frame is set up. Our return address is put in, and then we get all of our memory spots reserved for us for the number of bytes needed to hold data in. Because that's why it's so important when we're dealing with these types, integers, floats, etc. It's how that data is being stored and how much memory is actually needed to hold it. So that's all been set up now. And then we come through and we start copying data in. So we copy the data 5 into the parameter X, we copy the data 6 into the parameter Y, and then now we're ready for execution. Notice how I haven't executed anything yet. Notice how area is sitting here with nothing in it. This is just a way of kind of imagining how, and I guess a better way to have made this to look a little more interesting would have been just doing int area and just a terminator. Because then it would have looked more like what I've got showing right now. But the cool thing about it is whatever garbage is currently sitting there, whatever ones and zeros are being held in the little teeny weeny capacitive charges from the memory represents the garbage data that's there at the moment. But now in execution, our execution begins. Our stack frame has been set up. So here is our stack frame. For those of you from computer science, or you just love registers and all that, there's also other things that get set up for holding register states and things like that if it's important or if need be. But anyways, we're keeping it simple. So now we execute this line here. Area now has a place in memory. Now we remember how I always drew area or any variable as a box? Now there's our boxes. There's the real box. That's a real memory. So area equals whatever is currently inside of X and Y. At this point, these guys are the local X and Y. They're our X and Y. They're these parameters. And there they are. So with the understanding of that, we're going to use those two numbers. We're going to multiply them together. 5 and 6 is 30. So now we're down here to the return type. This 30 needs to get returned. And again, I'm going to have to say it's kind of by magic because we're not getting into registers on how data is being shifted around. Registers are special memory locations inside of our, they're special inside our processor and all that we can shift data into and out of very, very fast, as opposed to having to use the actual bus to go out to the memory that we put in memory slots in our computer when we build our machines. Okay? So, faster than USB? Asks Jonathan. Or actually, he as an exclamation point. And yes, way faster than USB by light years. Yeah, no, I know it was a statement. It was a very funny one. So now when we return, that 30 is remembered so that it can be sent back. And our return address is where we're going to return back to. See, we've held on to that. So here it comes. This is the important thing to understand from the entire night.
Whoa.
Is I don't want to use that brush. The entire thing from tonight is going to be not to use this brush. Hang on, let me go ahead and hit tab. Let's change our brush over to something a little more. Hey, I do art on this, okay? So back off.
That's awesome.
So let's go ahead and make sure that, all right, here we go. So we're returning, and I've activated my eraser. What happens when we return is we're unwinding the stack. Remember, when I added that stack frame on, what did I do? It's called winding the stack. I wound it. Now we're unwinding the stack.
So all that goes away.
All this goes away. Now here's the funny thing is, it's not like the computer takes any extra cycles to erase any of this. Not at all. It's still there. But it's now just random garbage, because the next time we do another function call, we're going to use this area, and we'll set up our slots to hold memory and all. And whatever garbage was there last time is going to be garbage that's just sitting there. So it's just garbage now. So in your head, the way I want you to think about it, because this is, I mean, in essence, this is exactly what happened. All of that just got deleted. And our execution, as we unwound the stack, comes back up here to this frame. This is what is now in scope. That is the word that you guys need to start thinking about. When you're inside a function, we're now dealing with what is in scope. And I saw garbage and heap being mentioned. I don't want to mention, heap is a different memory, different type of memory. And garbage, it is just garbage, ones and zeros that's there. So again, that's just for simplicity. Let's just think of it as we rewound the stack or unwound the stack. That's gone. And this is what is in scope. Okay? So now we're back here and we have this 30 that has been set up for us as our return value that we now have access to. And remember, we had that return address that told us exactly the line that we need to return back into for our executable code. So we return back into that line, and we've now resolved this figure area. We've now evaluated that to a 30, if you will. We've got the data for it. So now we can just take that 30, and that 30 is going to get written, as I bring through every eraser I have. That 30 gets written over here into the stack. This is our local area that we're now dealing with. That's the stack. So if I had a function call, and let's say that with figure area down here, it called another thing that said, I'm thinking, area, we're going to overwrite whatever's in area and call something called foo. Yeah, there we go. Very popular one. And foo takes in an X, a Y, and a third one. I'll call it area. So we have three things to send it. I'm not going to worry about defining foo here. I just want you guys to see what's happening. So we're back at this location again. We're making our first call. So right now area only has a 0 in it. This is the current stack frame that we're in. This is the frame for main. So now what's going to happen is we're going to call upon figure area. So figure area gets its frame set up. And I'm going to draw these a little differently to make it easier to see. So this is going to be our return address. And then we've got we get our parameter X, our parameter Y, our local variable area that gets set up. To make these frames easier to see, instead of drawing the lines all the way across, I'm just going to draw them like this. But let's stipulate it goes all the way across. Again, this is just for simplicity's sake. So now we have our stack frame set up. Code can begin executing. So code executes and all, but we get right here. what happens on this line? What do? We are making a what? We're making a function call. What are we doing right here? Foo.
Oh, okay.
We're calling a function called foo. And remember I said let's just stipulate that that's been defined.
Okay.
And Saturn had your back again. She's like, foo. That's right, food. So what happens when we make a function call? What happens with the program? A new frame gets put on. So a new stack frame. What's the first thing we get in there? A return address. Because it's not magic. It needs to know where it's going to return to. So let's say that this was address X000, and let's say that this was X001. So now X001 is going to be the return address that's going to be put in there. And this is the return address that's being put there. And for those of you that are like, wait a minute, that's not hex. I'm making up my own special hex. This is called Zex. Not to be confused with sex, which has nothing to do with hex. Okay, continuing. So we have our return. And then we see parameter-wise, foo took in how many arguments? 3. Look at Nina, go. It took in something, and I'm just going to put in an X. It took in something else. It took in a Y, and it took in an area. So I've wound the stack again. So you can kind of start to see where winding the stack comes from. And the mention of sex is not a PG-13 class, just for the record. They still better teach that in health class in school.
I'd
hope so.
I'd imagine, at least once.
So notice how our stack is growing. But notice how it's also going from a high to a low address. Not that that's anything important to you guys here. I just wanted to point that out. Because a lot of people like to describe the stack as going up the stack, and it really isn't going up the stack. So we have how many frames? How many stack frames do we have on the stack?
2.
Stack frames.
Oh, I'm sorry, stack frames.
We have this is a frame.
We have 1
containing its local data. This is a frame.
Oh.
It has its local data.
So you have 3.
We have 3 stack frames on here right now.
Okay.
But we're only executing at one specific place. And right now, where is execution happening? It's off in a lovely little place called foo. And here is foo's stuff. That's foo's world. That's the only thing that foo can work with. Okay? And as Thomas just said over in BuzzNet, this is very important for future with processors, with threads, etc. And that is so true. And for those of you that really get into the computer stuff and you want to start diving deeper and deeper into it, this very basic description of how the program execution stack works is so important for a base level foundation. The stack is actually super, super awesome how the whole thing works. This is a very high level look at what's going on. But it still gives you a pretty accurate representation of what's going on with data. Okay? So now we see why, or I hope everybody sees why when we're inside a function, how I've always drawn those as boxes. Remember I was like, we're going to do a main function. And so here's main. And then in this function down here, Nina's going to learn how to wash dishes. And in this function over here, Nina's going to learn how to burn dishes. So maybe main's going to call wash dishes, and wash dishes is going to loop through a whole bunch of stuff. And if something happens, then we need to call burn dishes because we need to burn that dish because it had dead little things in it that need to be killed. But remember, here's the key thing. When we're inside one of these guys, as I always like to draw them out as boxes, we're in a black box. We can only work with the stuff that's local to it. Those variables. Variables that existed back over here, we cannot see. Look at the memory back here, because now you can really see what's going on in the memory. I can't see outside of my stack frame. Unless, dun, 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 unless I start using pointers. You got it. Because remember, all of these guys are memory addresses. and to get fancy on you guys, they're all virtual memory addresses because our program can't know about real memory addresses. The operating system has to handle that mapping for us. Think about it. If our program knew about real memory addresses and we wanted to put memory in real locations, oh my goodness, we could have another program running there. That'd be horrible. So it's up to the operating system to handle where things get mapped to. And Jonathan said the chaos theory is what Thomas said. Very good. Jonathan said the exact, the right thing for those of you Windows users. Blue screen of death. Absolutely. So very, very important stuff. Now, when we're done with foo, what happens? What happens with our stack? We unwind the stack. Very good, Nina. But now remember, we got to return somewhere, right? So it knows that we're going to return back to the address that's currently being stored. What address was we storing in that location? X001. That's not this address. That was this address. And that's right. We're returning back to the caller. This is the guy who called foo. And if we have a result, that result, let's say it was 62. My dyslexia, I'm writing it backwards, is being stored over in a special place for us. And what do? We unwind the stack, as Nina said. This goes away. This is popped off the stack. And we simply use the last guy. See, this where we're returning to an execution, where's our code at? It's not where do we return to back over here. It's actually, to get more specific, our code's being stored down here in our text segment. That's where execution's really returning to, because that's where our code's at. These stack frames, they're just holding our data. So that's where we're really returning to. But that's back in this function, and that function owns this block. This frame is his. So again, this is the only thing he knows about. Okay, so back up in here, if we look at X and Y, we're looking at his own X and Y's and whatever values they are. So let's say we finished calculating area, and then let's say area ended up being 300. Now we're at the end. We're at the end of the function. So again, 300 gets stored. And we are now done with this stack frame. So we're going to unwind the stack again. We're going to pop this frame off. We're done with it. So again, we come in here. This is it being popped off. Everything in this giant blue space and all of the memory addresses is just garbage. So now, as far as our code goes, we're now back in main. So we're back in main. And main now lines up. So you can see that it's always the current stack frame. So you can see how it's not like it knows that that's its frame. They're always in sync. Because frames are put on, frames get popped off. Okay? So we wind the stack, we unwind the stack. Now, Marvin asks, when you unwind, are you releasing memory? That's different. When we haven't got into actually allocating memory yet. When we allocate memory, that's when we're going to start using the heap. So that is memory that's yet to come. And then we generally point to that allocated memory in a variable in our stack, in the frame that is using that. And that's when we have to get in there and start deallocating memory or releasing memory, if you're thinking from the Objective-C point of view and not using automatic reference counting. So hopefully that makes sense. Up to this point, the variables that we're using, these are all value variables that are being put on the stack. Once we start getting into the allocation of memory, instantiating classes, then we're going to start using this section of memory. And I will come back to this for you guys, and we'll take a look at how we're using that. And that is where we can start having memory leaks, because you're right. If you don't have a garbage collected system, if you're not using reference counting, which we'll be discussing that a little bit later, if you're leaving yourself as the person in charge of retaining and releasing or allocating and then freeing memory, and you don't do it, that memory will just continue to stay used. That's different. And Jonathan said, should teach us without using reference counting so we learn the right way. You mean without using automatic reference counting? Yes, and I will. Retain and releases, it's the way I learned it. It's important. So anyways, that's the stack. This, and I saw Marvin just said I need to rewatch this, and I feel a few other people might be thinking the same thing. And I apologize that this was, this big, long lecture on how the stack works. And I know it feels like there's a whole lot of stuff I just dumped out on the whiteboard. I mean, good heavens, look at this. It just looks like I vomited text all over it, or white little scribblies at the very least. This is important. This is extremely important for the simple fact that you can really visually see why the local variables are called local variables to a function. Because you can see those local variables are inside that function's stack frame that it's using. And you can see why after a function's been called and we return back from that function, it's all over. That function's memory is gone. Okay? How applicable is this across other languages? Asks Jen. Very, very, very similar. Very similar. There are different kinds of stacks out there, and there are different kinds of program execution stacks as well, in the way that the mechanics and all work. But what I've described here, if you're going to jump over and start programming in C# or anything like that, it's the same thing. Okay? And doesn't the stack vary across CPUs? Yeah, the way CPUs go about using things can definitely vary. But that's why you use a compiler for a specific CPU, because then that compiler understands the registers that it has available, the high, the lows, so what serves as scratch pads. It knows how to optimize for that CPU, and it handles setting all that stuff up. But then as far as how the actual stack is working, comes down to the operating system. Because if you think about it, it's the operating system that's now responsible for taking and setting up the memory, mapping out the virtual memory back to the real world memory, to the real memory. Do you see what I'm saying? So that's the actual operating system at that point. But as far as what you said about the CPU, yes, I mean, because again, registers and all of that stuff have to be handled in a specific way. So the compiler has to be compiling for the CPU type that you're targeting. So this is a much closer analytical look at what's going on when we run our cute little bitty teeny programs. This is not something that you have to memorize, and I'm not going to be testing you guys on this. And I know for those of you that have been over in some of my other classes that have taken tests in the past are probably saying, thank God. But this is important in understanding the concept of local variables. And here in a few minutes after we take a break, also in understanding recursion. So what I'd like to do at this point, if there are any questions, please feel free to ask. Marvin has asked about when will the open office hours be, which is a fantastic question. I do need to take a look at the calendar because it wasn't important on week 1. It's going to become important now. And then we will, and I'll let you guys know, because we're also, as of next Thursday, will be an open office hours for drawing as well in the evening. So it's challenging. I'll figure it out. But what scares me is I don't know if I'll be able to give you guys open office hours at like this time, the 6 o'clock time. I'll see what I can do. All right, let's go ahead and take a break. Everybody stretch your legs for 10 minutes. Don't become stressed or overloaded with what you've looked at, what I've just gone through. I feel it's very important for beginners to see this. You guys have seen me drawing boxes. I think that's important that now you kind of see these boxes and when I say memory locations and stuff like that, you kind of see a big picture of it. So break time, pausing video, and when we get back in 10 minutes, we will go from here over into the wonderful world of recursion, which is when we deal with a function that calls itself. See you guys in a minute. Thank you. Welcome back, my dear friends. Glad to see you guys are still hanging out with us after so many hours of lecture and seeing that, wow, we've almost been at it since for 4 hours now. I am highly impressed to see that I think we've only lost one person, and that blows my mind. So what we're about to do is get into something that is called recursion. So first thing up, I want to go ahead and give myself lots of new... holy smoly, I did not mean to do that. Here, just close. I meant to hit the keyboard so far away. Miserable. Don't feel at home working, not even using a mouse, using fingers and trying to use tablet on thing. Yes.
Armpit.
Yes, and I'm working crisscrossed arms, which is funny too. All right, so yes, we're almost done. We're getting close. Welcome to Recursion. This is where we're going to spend the next 5 hours tonight. So go ahead and just get yourself comfortable because we've got a few things to talk about. Yeah, pillows, maybe. So here we go. So recursion. So what is recursion? Recursion is when a function calls or invokes itself. Whoa, that's kind of trippy. So like, here's main. And let's, here's Nina wash dishes. This is going to be awesome. And let's say when Nina learned how to wash dishes, something went horribly wrong. And so there's recursion. So when somebody walked through, you know, here we are doing our thing, and then there was a call to Nina to wash dishes. So here's recursion. Recursion is if somewhere along the way we have a call, wash dishes, to ourself. So what happens? We call ourself. All right, fine. So we're now calling ourselves and we're running again. So let me draw this out, if you guys don't mind, real quick. Here's our stack. We start out with our first frame. It's been allocated from main, and maybe it's got a couple of things in it. And then we called upon washing dishes. So as we all know, wash dishes is going to get its own stack frame. And now we have the local variables and stuff that's in it. Oh, we just called wash dishes. So we got another stack frame that gets added on. And first thing, you know, of course, we're going to remember our address, just like up here. First thing we remember is where we return to. So when we return, execution is going to bring us back up to looking at this guy. Not that we're executing code in there, but we'll be popping that frame off the stack. So just keep in mind that's what's really happening. All right, so we're now in here. We're washing dishes. So we got all the variables and stuff set up. Now execution goes on. Now all of a sudden in the middle of washing dishes, Dina's like, I need to wash dishes. And she starts scrubbing the dishes again. We remember where to return back to. And then are we starting to see a pattern of something very bad that's happening here? If there is no sort of control used to cause us to exit out, what am I doing with my memory right here?
Running it, like filling it up.
I'm filling it up. What was this called again? A stack. Have you guys ever seen this incredible thing called a stack overflow? You've probably seen a stack overflow before. For those of you in the computer world, because Nina just looked at me like I was completely stupid. That was the best look I've ever seen. I'm like, whoa, I am not that dumb, I promise.
No,
All right, maybe.
that wasn't a you're dumb look. I was like, no.
And for those of you like Exion who's only heard of it as a website, yes, it's a fantastic website for asking questions and all.
I pictured like a stack of laundry overflowing.
Yeah,
something.
we
I was just picturing things.
We eat up all of our memory. We end up with a nice, juicy error. We end up with a stack overflow. Very, very bad. Stack overflows are bad. Buffer overruns are bad. There's all sorts of things that are bad. Okay. So in this particular case, this is what we'd be looking at, an overflow. We don't want a stack overflow. So if we are using a function in an algorithm that is going to call itself, that function better know how to exit out of itself at some point in order to, and now remember, we know that when we say return back, what we're really talking about is return back to the actual executing code that's held in the text segment of memory. But in this case, I'm just going to,
So if one of those functions was stuck in a loop, that would cause this?
yeah, well, if we just, if we had a loop and inside, if I said print hello world and then inside, yeah, you really want to have fun? I mean, I'm scared to do it. I don't.
I think Scion said he did it. Somebody did it.
I mean, if I wanted to do this and inside add instead of returning it, like if the very first thing I did was to call add, and how about I say, I don't want anything to, I don't want to have to get into certain discussions yet. So let's say x equals, and then I call add again, and I send what was in num1 and num2 to it. Yeah. I terminate that. Let's make sure I print at the very beginning. Num1 equals %d, and num2 equals %d. Watch me kill the entire webinar. That'd be so epic.
Oh, no.
And then I'm going to pass in what num1 is and what num2 is. And I would hope that my compiler is going to be somewhat of a good boy. Now,
Okay.
we're not using x. Let's just say we're going to return x so that we're making use of x. And then good. So all good. All right. So hopefully, I'm hoping that in this particular case, Xcode is going to be nice and slick and not let me destroy everything. But hey, I like to live on the edge. You guys like to live on the edge?
Let's do this.
Let's do this. If it all blows up, we are recording on a different screen, and we'll just put up a technical difficulty sign. So let's save and let's analyze what the execution's going to do. So coming through here, let's do that. So inside of main, we set up X, we set up Y, set up total, and then we're going to make a call to add. Sweet. So we remember this on the stack as our address that we're returning back to in our new frame. We're now going to come down here and we're going to print some cool stuff out to our output window with a new line in case it's nice enough to print anything. Then we're going to come down here and what are we going to do? We're going to call, wait for it, ourselves.
Call ourselves.
And then we're going to come and print something out. Then we're going to come down here, and what are we going to do? Oh, wait for it.
Call ourselves.
Call ourselves. Oh, my gosh, it's so funny. Let's do this. So here we go. Saving, running, building. Oh, my gosh. Oh, my gosh. Look at all the numbers. Uh-oh. We've got a problem. Houston, we have a problem. We have a spinny thing. Oh, come on. Be nice enough to show me the actual Stack Overflow error, because the new debugger is just... The new low-level debugger is just nowhere near as nice as the old.
Science said I lost video. Look at that joke.
Ta-da! Hey, we got something over there.
Ooh.
Sweet. We got all sorts of really cool stuff where we just blew up inside of our thread. So execution's been paused. Exec bad address. We're out of memory.
You made Xcode cry.
I did. Oh, by the way. Don't follow me at home.
Yeah, don't follow along.
Am I a little late at saying that? Don't attempt this at home. We should avoid writing things like this. But I wanted you guys to see the world of trouble that we were getting into. Now, I don't think we're going to be nice enough over here to see anything yet issue-wise because it's not. But it is pretty funny that we just saw everything explode, and we're looking at assembly right here. So this is really cool stuff in itself, in the fact that we're actually seeing how we're doing tests and moves and jumps, and we're moving data from particular registers over to other addresses, and data into registries and things like that. There's a lot of really cool stuff, and man, let me tell you what, this would be a fun class in itself to cover this. But that's pretty low-level stuff. But what we've just done is created a Stack Overflow. We ran out of memory. So I'm going to go ahead and hit stop. Stop. No, I'm just kidding. Okay, we're back. And we're now going to take a look at how we can set up a recursive scenario that does not cause the world to go boom. Because that was boom. You don't want to give that to someone
That
anyways.
was the big boom.
Yeah, it really was. So I'm going to write out a very simple program. As a matter of fact, let me jump back to the whiteboard. You guys all good? You still with me? Yes? Good? All right, good.
Nobody blew up their computer.
No. All right, good. We've got one yes or a Y, but I'll just pretend it's a yes. No, I know it is. So what we're going to do is write a simple program. So let's do this. And I'm going to do a little bit of pseudocode in here. Int main, and I'll put it right here, even though I was about to put it at the end. So
No!
first thing I want to do is I want to print out something that's like starting or in main. In main. Just in case there's any confusion, everybody knows we're in main. And then I'm going to call a function that I'm going to title recursion. Now get this. Here's the big one. With this call to recursion, I am going to be passing data to this so that I can watch what's happening with data and so that I have data that I can use to control when all of this stuff comes to an end. So I'm going to pass the number 5 over to it. This will make more sense in a moment. Then I'm going to print F, again, pseudocode, back in main. So this is just little printouts to our console to let us know where we are. Guys all having a good time? Good. If you're not, shut up. Just kidding. All right, so, no, really, shut up. So after we print that out, of course, we'll do the typical return 0 and end. All right, so the next thing that I want to do is go ahead and define, remember all this fancy language that we know? Oh, we're going to stipulate that we've prototyped it out up here. So we're going to define our recursion function now. So this guy is going to return nothing. Often, very often with recursion, you're going to be returning something, and that what you're returning is what you're going to use to determine if you're going to start unwinding the stack, to start bouncing back out of these functions, okay? But I'm going to do this a little differently. I'm going to keep it super simple, but we can see what's happening on the stack too, and I can tie all of this stuff together, which is going to be awesome. And you better think it's awesome, because look at all this extra effort I'm giving you guys. All right, so here we are. We're going to call this recursion. And we already know recursion better take something in because we've prototyped it out. So I saw that, Jonathan. So this is going to take in an int. And let's just use the thing we've been using, num. Yay. Sorry, having too much fun with num. All right, here's how I'm going to do this. If num is greater than 0, what I want to do is I'm going to print out, and I'm not even going to use format specifiers and all of this stuff. Yeah, I'm probably using num a lot, as Thomas just pointed out, because I'm starving, so I'm thinking of num, 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 num. So what I'm going to do here is I'm going to use big-time pseudocode, and I'm going to print out what is inside of num. So I'll just say num. I can't even spell num now. Num equals, and then print out the number. Yeah. I'm sorry, because we'll just print out whatever. You get the idea. But what I'm thinking here is another print statement. Yeah, my apologies. I'm changing my code here. Just a little bit. Because I really want you guys to see this. So I'm going to start out with a print. Yeah, this will make more sense. Showing that we're creating a new stack frame. So now we can see where our memory is getting put onto the stack, each stack frame. So creating new stack frame. Stack frame. That's what that San Francisco now stands for that. And then what I'm going to do is I also want to let us know what num is at this point. So num equals whatever it is. That's not an N or an M. Then I'm going to say if num is greater than 0. If it's greater than 0, I want to keep doing this. So I'm going to say, let's call ourselves again and pass num. And now let me introduce a bug. I'm going to pass num to it. Terminator. Otherwise, we're just going to say, let's just print out leaving, so we know we're leaving. Leaving. Or how about unwinding stack? Yeah, that's because we're all fancy now.
Oh my goodness, my handwriting is...
Look at my handwriting. Jeez.
Woo-wee.
Unwinding stack. There you go. That's the whole program. So now if I wanted to real quick, which I do want to, so yeah. I'm going to come over here. And start out, let's give ourselves a little bit more room. Let's trace it, because tracing's fun. We're going to start out with our first stack frame, and well, there's nothing really in it. So yeah, this will be our first stack frame that we will get to return back to. All right, so we're going to call recursion, and I'm just for the sake of time, I think 3 will make things a little bit easier for you guys to see. So I'm going to call recursion with 3. So a stack frame gets set up. And inside this stack frame, we have our return address so we know where to continue back from. And then we're going to be holding what is currently in num. And so we'll just give the rest of this giant memory area num. So num is holding a 3. Okay, so that's a memory location. So we go through, we're going to print out that we're creating a new stack frame. So if we looked at our console, we got in main. And then on the next line, since we just called recursion, we've got creating new stack frame. And then we've got num equals, and what's currently num?
3.
3, absolutely. So now is num, so remember, that was this execution. So now we're going to go down to the next line. Is num greater than 0?
Yes.
Yes. So what do we do if it's greater than 0? Well, we don't do that. That was like a drunken driver crashing a line.
You do the recursion.
We call recursion again. Well, what does that do? Calling a function is going to create a stack frame. So we have a new local stack frame that gets created with our return address that we know return to for execution. And over into it, we're going to, we have one memory location set up to hold data, to hold num, because that's the parameter that it's, we've got sitting there waiting for our data to come in. But the problem we have right now is I'm going to send a 3 into it. And we've already seen that we've just tried to set up recursion, but we've done, yet again, an infinite loop. And we're just going to keep adding these on because nothing is happening to num.
Right.
Now, remember, a second ago, I told you guys I was going to introduce a bug. So here's another example of where we have the loop, or excuse me, the recursion causing our stack to completely fill up.
Right, because it's always 3, so it's always
greater
3 than 0.
So now I'm going to get all fancy, and I'm going to come in here, and I'm going to do minus num. And that was the worst thing I've ever wrote. I think I'm going to throw up in the back of my throat. Okay, so let's...
Hey, that was actually pretty good.
Thank you very much. I normally don't share my songs with people like that. We do that around the house, but not for you guys. You guys are lucky tonight. So, and that's still the wrong brush, so that's probably the wrong brush too. What brush do we have up? Yes. There we go. Thank you. Jeez. So let's put minus num. Quick, answer me this, everyone. What was that again? What operator was that again?
It's a pre...
Ooh, you're cool.
A prefix?
Awesome job, Nina and MMO does, because Nina didn't see you. It is a prefix decrementer, which means we're going to decrement first by 1, But first, it's prefix, meaning before we do this line, we execute this line, we first make that number go one smaller. So currently, this 3 right here became a 2. Then we actually create, now, after we do this, so I showed you a bug. Bug is now fixed. Now we're going to come in and call ourselves. So we're calling ourselves. We have a new stack frame that just got created with the address where it knows where to return back to an execution, to our caller. And we get num passed to it, which is currently a 2. So now we started out in main, and then main had called recursion. Check this out. Recursion just called itself. So here it is again executing. So now num is 2. So the next thing that needs to happen is, and this is, you guys are going to enjoy this, I think. So we've just finished, excuse me, no, we're back in here. So we're going to get printing, or creating a new stack frame. And then we're going to get num equals
2.
Now, our next bit of fun. If num is greater than 0. Is num greater than 0?
Yes, because it's 2.
It is?
No, it's 1 now, isn't it?
Ooh, is it 1?
Oh, no. Does that happen first or second?
Come on, guys.
No, so it's 2 now.
It's still a 2.
It's still 2.
That's right. You
it gets
see, I
ridiculous.
haven't changed it.
Yeah.
When I change it, I'm going to act just like the program. I'm going to change it. So it's still 2. So we printed out 2. So now execution went from this line down to the next one. And is 2 greater than 0? You guys said yes. So what are we going to do? We're going to do what?
Call.
No!
No! Wait,
It's a prefix.
We do the prefix, so now it's 1.
That's right. So we're going to take this 2, and we're going to set up a what? We're going to set it up as a 1. We just overwrote it. Right?
Yes.
So now what are we going to do, Nina?
Now we're going to go.
Now we're going to hit tab because I know I just changed my stupid brush again. I got to change that parameter back to forcing me to use a shift key. Okay, so now we're going to call recursion.
Call recursion now.
So that means, once again, a new stack frame gets set up. We have a return address, so we know where to return execution back to. And we pass whatever was in num to it, so
1.
into the parameter, which is a 1. All right, so now what happens? We're now into another one of these guys. So first thing that happens, again, execution is starting out right here in that new guy. So we're going to print out blah, 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 blah. So creating a new stack frame to let you guys know we just created 1. And then we're going to say num equals what?
1.
That's right, num equals 1. And then we're going to come in here and we're going to say, is num greater than 0?
Yes.
All right, so num is greater than 0. So if it's greater than 0, what are we going to do to num? Because we just checked this. You said yes, so we go down to here.
Then now we subtract.
Ooh, look at you. You're getting
1
good at this
from
now.
num.
So now we're going to decrement. So we're going to take 1 and make it a 0 because we're still in this frame. Then, after that, we call recursion again. So what is that going to do?
It's going to put, oh gosh.
It's
wait,
gonna-
going to make another.
Yeah, it's going to make another stack frame because
Stack
we've
frame.
just called, anytime we call a function,
Makes another stack.
we get a
frame.
stack frame. So we
When
get a
you
new
see-
stack frame.
yeah.
We have an address on where we're going to return back to an execution. And we set a parameter to it. What did we
0.
send? We sent 0. All right, very good. So now we come back up here and let's do what's in it. We're going to say creating a new stack frame. Then we come down, we say num
Equals 0.
equals 0. And then we're going to come down to, is 0 greater than 0?
No.
No. So now what's going to happen? We jump over that.
To
We hit right there.
say unwinding the stack.
And so, yep, so now I need to come in here and no, I don't want to do it that way. I actually, no, would you go away? Thank you. All right, so let me just, here. We get the idea what's going on there. So besides, we have a good, because I'm about to need several more things there. So now we're going to get unwinding. So I'll say U for unwinding. Unwinding stack. And where are we at?
At the
End.
end of
Great.
that function.
We are at the end of the function. When we're at the end of the function, what do we do to the stack, ladies and gentlemen?
We unwind.
We unwind the stack. What does that mean, ladies and gentlemen?
So all that becomes.
All that becomes
Garbage.
Garbage. I love it. This is gone. This is just look at it as this. It's deleted. And the return execution. Now remember, I'm just using the stack frame to show this. Execution's actually elsewhere, but we just return back to this guy. All right? So just think of it like that. But this is the frame this is the active frame. We always use the active frame that's there. And Jonathan is right. The data is still there. But it's garbage data. It actually is still there. We do not waste we don't waste CPU cycles to go and clean that up. That would be a waste and very inefficient. But it is garbage now because heavens knows what functions will be called next and what stack frames will be created and all. So now we've come back to, and I'm just looking at it as I'm just showing you our active stack frame. So we've now come back to the recursion method that is the caller of the final recursion method. So we're now back here. So we're at this guy. So back inside here, the last thing we did on him was this line. Was that not where the execution was? That's the address that it took us back to. So that means we execute the next line. What does the next line do? Prints out, unwinding the stack.
Oh, my goodness.
Now you're seeing recursion. This is how we're going to unwind all the way back. So now what are we pointing to? End of that function. Well, if we're at the end of that function,
unwind the stack.
We have the address. We know where we're going to return back to, so we're going to come in here and unwind the stack. That's all gone bye-bye. That's just garbage. And so we're now back into this iteration here, okay? Again, so we're into that copy, that running copy of recursion function. It's in memory. Well, we're into that stack frame. So inside of this stack frame now, where were we at? Remember, we had an address that pointed. We were right here. That was the caller of the guy we just exited out of.
So then you have to write unwinding the stack again.
So you got it. So execution goes to the next line. We're going to write unwinding the stack again. Execution goes to the next line. We're at the end of this function. So what happens? We're going to unwind the stack. We know we have the address right here. We know where we're going back to. And we're going to come in here and get rid of this guy. Notice how our stack, we're no longer running out of memory. Our stack is starting to free up. If we would have had this infinite recursion call, we saw that the stack kept getting important data added to it, kept getting all these stack frames. Even though the data is still sitting out there from these other frames, they're no longer, they're what's called active records. They're no longer records. They're gone. Those stack frames are gone as far as stack frame is concerned. It's just junk data. When they are active records that are important, when they're actual stack frames, and that we keep pushing new stack frames onto the stack, well, the program, the operating system knows we got to keep all of that. It doesn't go into it because we're going to have to go back to it. So what happens is we run out of memory. Here we're not running out of memory. What you're seeing is we're freeing our memory up. Because at this point, the only thing we've got sitting on our stack is two frames. Mains frame and the first recursion call we did. So now we're back to the first recursion call. So here we are back to this guy. So we're back inside. Where do we return? Where did that address point to?
Minus. No.
That address returned us right back to the call. So we're back in there. So we did that line. There's nothing else to do on it. We come down to the next line. What are we going to do?
Print unwinding.
Unwinding stack. Execution down to the next line. What do we do on the next line?
Unwind the stack.
We have an address. We know where to return back to. Oh boy, we're returning back to this very first stack frame. We're returning back to main. So let's go ahead and come in here. Let's keep this guy looking as clean as we can because we don't care about anything that's in there now because as far as the program's concerned, that's all garbage. As far as the program's concerned, there's nothing there. It's all free memory. That's what you need to understand.
Huh.
So now we're back in the main, but we're back to right here. So now right here, we're going to say, oh, we've already done that line. So we go to the next one, unwinding, blah, blah, blah. Oh, wait, we just did that. We're back to main. My bad. I I threw an extra one in there. Haha, that's me. It's getting late. So we're back in main. So where does that mean we return back to? We return back to the caller. So did I actually write an extra one just a second ago? Did I write that guy out? No, I didn't write him out. I think I caught myself. I hope I caught myself. Well, we'll find out in a minute when I type it out for real. But anyways, so we're back to the caller as I go through all the stupid brushes again. There we go. So we're now back here at the caller. There's nothing else to do on that line. So now we're down here, and we're going to what? Print out back in main.
Holy moly.
Then we're going to return 0, which means at this point, the program's done. We return 0 back to any calling application in case they're going to use it. And our memory, we're done with the program. Memory's all given back to the operating system for the operating system to reallocate as need be. Thank you very much, Thomas. Sound like a mad scientist. Yes, sir. That's recursion. Students have a hard time with the concept at first. Recursion's so powerful. It's so useful. One of the things that I used to have students do in my Maya class all of the time was after they had the concept of recursion down, I wanted them to take a skeleton. Okay, so I know this isn't a Maya class, but I wanted to show you an example of how recursion can be useful. So inside of Maya, or any 3D application, so I'm just going to represent these guys as joints. Haven't drawn one of these in 3 years or better. Wow. Okay, he's got short stubby legs or a very long torso. I would have people in a very, very simple function recurse through all of the joints in a skeleton. Because you could start at the root. This is the root. Notice how it's the center of everything branches out from there. Well, let's just say this is the root. I don't, you guys that don't know Maya would be like, what the hell is he even talking about? This class is just like really irritating me now because this ain't Maya. All right, so we're starting out right here. Sorry. So, this is our root location. So if we move by the root right here, the entire guy is going to move around. So what happens is, so this is a hierarchy. Are there any children here? Yes. Child, child, child. Okay? So we could explore a child. So we're starting out here at the root. And maybe we start here. And we first go and we put our attention. So we call the function to recurse through joints. So we call it and we pass this joint to it. And so to say this is our left hip. Okay, so what we do with left hip, we then say, are there any children from it? Well, there are. So this is the hierarchy. I'll draw little arrows just so we can see. That'll probably help. You guys like my arrows, don't you? You know you do. You just don't want to admit it. That's okay, though. All right, so we're at the left hip. Left hip have any children? All right, yes, it does. So let's pass in the child. So we were looking at this. Now we're going to pass in the child and look at that. So again, we're going to recall this exact function again, passing that child. So now we're looking at, oh, wow, this guy has a hip and a foot. Oh, well. So his left foot. Yeah, you can see I haven't done 3D in a while. He doesn't have a knee. Awesome. So we're looking at his left foot. But check this out.
Oh.
We ask ourselves in the function, so these are inside functions where we pass the joint name to it. We ask this guy, do you have any children? Now watch this. Nina doesn't know 3D, and I can ask her, does he have any children?
No children.
No, he doesn't. So watch how this works. We then return back to this guy who is looping through all of the children. Are there any more children to loop through?
Yes.
No.
Oh, wait.
If so, then he's deformed.
Oh, wait, hold on.
So here's his pelvis, and this goes up to his spine. Here was his hip, and then he had a foot. If he had more children, then he's got some weird stuff going on.
Oh, I'm sorry. So you don't go back down the leg back to the foot.
No, we went from here, so we worked our way down.
Okay.
So we started here, Then we went here.
Okay.
Then we went here. Now there's no more children.
Right.
So we went back to here. Are there any more children? No. The children was just down the hierarchy like that. This guy above is not a child. He's a parent. Okay. So now, since he has no more children, we return back to the parent. Does the parent have any more children?
Yes.
Yes. He's got a spine, and he's got a hip over here.
Hip.
So we'll take this hip and send it in. So check it out. We now are looking at this guy. So our control now is over here. So we call the function again looking at this. And then we can say, do you have any more children? He does. He's got a child down here. So we look at that guy's child.
Okay.
Does he have any more children?
No.
Nope. We're at the end of the chain. We're at the end of the hierarchy. So what happens? We go back.
To that dude.
Does he have any more children?
No.
Nope. The only child under him was our foot. So now we return back to him, which is back up here. Does he have any more children?
Yes, because they go up.
Now we can go up to him. Yes.
Area.
So now check it out. We'll call ourselves again, and we'll pass this guy to it. Notice how I'm actually reconstructing the whole thing over here.
Little dude.
Yep. So it's going to be like he's going to do his thing. He'll call himself again because he's got a child. Then this guy will say, does he have any children? He's got 3. But he's going to call this guy first, and he's going to ask this guy if he has any children. This guy will say, do I have any children? Yes, I have one. Okay, so we're now on this guy. Do I have any children? No. So we go back to this guy. Do I have any more children? No. We go back to this guy. Do I have any more children? Yes. So we call ourselves again, passing that child. We're now this child. Does this child have any more children? Nope. All right, so we go back to this guy. Does this he's got a neck now. Awesome. All right, so we return back to this guy. Does he have any more children? Yep, he's got one more. So we return back to, or we go to this guy. Does he have any children? Yes. He has a child. So we go to that child. We're now at this child. Does he have any more children? No. So we return back to him. Does he have any more children?
No.
No. We return back to him. Does he have any more children? No. We return back to him. Does he have any more children? No. We return back to him. Does he have any more children? No. We're out. We just went through the whole, and of course I don't expect you guys to do this, and I know that was just a very sloppy showing you, walking through an actual hierarchy. And we used a hierarchy, and we mimicked it with recursion. Okay? And I know I've got all these people out here hollering out BSP trees, and when you start getting into data structures and the things that we can do.
At least he's somewhat following Derek's head length recommendation.
Nice. Very nice. No, I'm not. I'm not even close. What are you talking about? Derek would throw up if he saw this. So let's go ahead and jump over real quick and type this out now. So I've explained it now a couple of times. I've traced it out on the stack with a very simple recursive program. I've had you guys cruise along with me and follow it. So he took a screenshot and you're going to give it to him. Look at you. I'm not cutting you any slack no more. Extra whips for you. All right. So let's now go ahead and jump over into Xcode, and you guys are going to have to help remind me what this program is going to do. So back over here in Xcode.
Going to say some stuff and things.
And let's kill out some of this junk we don't need anymore. I'm just going to put this whole thing together. So we know that we're going to prototype out a function called recursion. We said that it had no return type. So we're going to do a void recursion. And we had said that it takes in an int num. And this is a function prototype. It requires what at the end? A
terminator.
That's right, a terminator. Good job. So now let's go ahead and define our function, because at this point we've just made a really crappy promise to the compiler that we're going to have that function. This is like we're about to cheat on our girlfriend or something. We've made a promise that we're going to be faithful, but then we're not. So let's go ahead and define this and make sure we're nice and faithful people. So we're going to jump down here and put together, what did I call it? Void recursion and very good with int num. Sorry, just trying to do a little thinking here. Oops, not with the backspace. Stupid keyboard. And why you keep wanting to hit that button? All right, so now we're going to put this little guy in there, and now we're going to start coding, but not with extra spaces. So starting out right here, we're going to do a print. Now I can't use pseudocode. Boo! We're going to come in here, and this guy said something like creating stack frame. Yeah. Except I'm going to spell it right because that's cool. Creating stack frame. Then what we did is we wanted to say what our num is currently equal to. So I'm going to say printf, and let's jump over here and do something like num equals and percent the backslash n, and yeah, looks good. Oh, come on, I'm typing slow. You should be able to get this.
No, I made a boo-boo.
And we're going to print num out. So then we're going to come down here and we're going to say print. No, we're not. We're going to say if. And what is our condition going to be? We want to say if our num is greater than 0. And now I'm going to tab on down, and we're going to do what? We're going to call recursion, and we're going to pre-decrement num so that we don't get a cool little problem. And if you guys recall, we're only doing a single line, and you guys all know if we're not doing compound statements, we don't have to do this. Put some extra enters in there for Nelson. Okay, just kidding. All right, so now, after we're done with all of this recursive stuff, we're going to do another printf, but spelling it the proper way, right? And we're going to say unwinding the stack with a new line. And let's go ahead and terminate that. And, whoops, believe it or not, I mean, it's pretty straightforward. Let's just jump on up here now and make use of this. So in main, what did we say? We first started out by saying printf. We're going to say in main, woot. Well, we're not saying woo, but you get the idea. And then we're going to not return 0, but instead we're going to jump down here and we're going to call recursion, and we're going to pass it, I did a 3 over there. And then we're going to print f afterwards, saying that back in main, woot, new line, and then we'll call it.
Okay.
Make sense?
Void recursion. Int main. Void.
You guys know it makes sense. It's what I just wrote out over on the board. What's wrong with you? You know it's working. It's going to work.
Do work.
So let's go ahead. I'm going to jump down here. I'm going to clear this out. Are there any bugs in this? And are you sure there's no bugs in it? Sure? Absolutely positive? I'm going to take a quick sip of my pink energy and pause the video while you guys type this out.
Void recursion.
And I'll pause the video.
No.
And we're back.
Yay!
Sorry about that. I almost started and...
hey, let's pretend to do it all over again.
Yeah.
Hey,
so
did my thing run?
Nina just ran her code as she finished typing it, and it ran beautifully.
Woo!
Good job. I think that's the first time I've ever forgotten to start a recording back. You guys didn't miss anything much, really. Okay, you missed me hitting the run button. So I just executed mine, and you can see that, let's come in here, bring this up. In main, creating stack frame, num3, creating stack frame. So here's my control number, and I'm calling it my control number because it's what I'm using to control my recursion, to make sure that I don't end up with runaway recursion. I don't run into a Stack Overflow and my program prematurely terminating. So with a horrid error. So num2, creating stack frame. Num1, creating another stack frame. Num0, unwinding the stack. So look at this. I created 1, 2, 3, 4 outside of mains. So I created 4 stack frames. I unwinded, got rid of the first one. So, well, actually, it's looking this way. So first one, second one, third one, fourth one. I created 4 stack frames. I unwound. I eliminated 4 stack frames. Ta-da.
I'll be John Brown.
I'll be John Brown. That's a good one, Miss Nina. I'll have to remember that. Ladies and gentlemen, I hope that makes sense to you because that's recursion in a nutshell.
Yeehaw.
I mean, it really is. You want a quick recursion exercise? You guys want one that you can calculate, figure out, type in, and do yourselves? You know you do. It's only 10:35. We got plenty of time left to type out some stuff. Now, it's challenge time, ladies and gentlemen, and there's no way. All right, so Jonathan already submitted one, but he failed because he submitted it to the wrong submission screen. Oh, So that means Jonathan can go to bed, but everyone else, you know you want to do one. Everybody's ignoring me but Jonathan, and that's only because Jonathan actually turned one in. Why are you guys ignoring me? You know you want one.
They're hiding.
There's something. You know what? I'm saying like it is really. Well, MMO does. I asked a question waiting for the challenge. I asked, do you want the challenge? Oh, look at that. Mr. Wizzykin is all over this. He's writing one that counts up from a number to a max and then back down. That's awesome. Oh, then back up, then back down. He's creating a sine wave. Awesome. With amplitude control. Yeah, that's what we'll call it. A very, very simple one that we will give. Write the following. Hey, Nelson. I don't know. Hey, you're still awake. Awesome. Do me a favor. Go ahead and create a new submission code thing in BuzzNet and call this one Recursion Challenge. I want you to write a simple program. It'd be better started that way. I want you to write a complex program, a simple program that's going to find the sum of all positive numbers from 1 to a given number. What the heck do you mean by that, Mr. Busby? I just don't understand. Well, let's go ahead and jump back over here into Photoshop because some of you that may be getting tired right now, oh, hey, look at that little guy right there. He's pretty cool. Might think that, what is he talking about? If I wanted to run, and let's say I want to call the function sum, and I sent in a 3 to sum, what am I going to get back?
Wait.
So here's what I'm wanting you to do. And my explanation probably stinks, but this will make it easier. Whatever number you give, start at 1. So let's count to 3. The best class ever. 1. Come with me, Nina.
God.
2, 3.
3.
So the number that you send in is your high-end number. What I want you to do is from starting at 1, I want you to add all of these numbers up and return the result. So the sum of 3 would be what?
Oh, what?
Nina,
Wait.
1 plus 2 plus 3 is?
I'm sorry, 6.
6. So this would be equal to 6. So what would the sum of 5 be? This will just let me know that you guys are all over this.
Then you do, what, it'd be like 1 plus 2 plus 3 plus 4 plus 5.
So well, let's write 1 plus 2 plus 3 plus
6,
4. But what? You're killing me.
15.
Yay! 15. Oh, you were adding them up.
Yeah. You thought I was messing
I was
with
like,
you.
what? So 15. So the calling on the sum of 5 is going to print out 15. And that is how I want this to work.
Okay. So what are we doing again? I'm just kidding.
I want sum. So here's what the prototype, I'll get you guys started. Here's what the prototype for sum is going to look like. Int sum int, and let's stick with num since that's what we've been using all night. There's the prototype. For those of you that are watching this video later, this is a great time to pause it and see if you can do it. So your program, your main, will just simply call sum and then print out whatever sum returns, which needs to be the right sum. If you cannot get this, that is okay. But I want you to try. This is a challenge. If you cannot get this, you will only be expelled from the class once. Oh, wait. That means you're expelled. That means you're out. Just kidding. So you can do this. I have faith. Or at least give it a try. Ashley, have you finished and submitted it yet? You have no time to have your eyes bulging out in chat if you have not yet submitted it.
Oh, my.
Type! All right.
Okay.
With that, we will go ahead and take a quick break as far as the video is concerned, and we will be back momentarily with answers. Welcome back, ladies and gentlemen. So the first thing I want to do is I want to point out that there are a lot of different ways that you can manipulate the data in order to do this. Now, I know that we've got several people in the class right now that have given this a valiant effort, have really tried. I've got Nina over here just cringing on the edge, trying and trying and trying.
I tried. I deleted.
And you guys that are trying, I truly appreciate it because that's what's important. But it gave me an idea. Here's how I'm going to handle this. Oh no, Jen, she didn't get it.
No, I didn't get it.
She thought she had an idea a minute ago, but then it didn't work out. What we're going to do is I'm not going to explain my code. I'm going to code it for you, and then I'm going to let you guys work out so you guys can follow along with the code, but I want you guys to work out the logic of it using what you've been taught to see what is happening. So let's go ahead and jump over into Visual Studio. Man, what's wrong with me? Let's jump over into Xcode. That's what I meant.
Please jump over to Visual Studio.
Man.
I would prefer it if you did, really.
I know. So let's go ahead and reprototype this out. What we're going to do is we're going to call int sum int num.
Oh my gosh, I got that right.
Ta-da! Good job. All right, if you got this, good deal. So we're going to get these guys out. I'll leave the print in there because we'll be using that in a minute. All right, let's go ahead and define our function, sum. So we already know that it's going to be int sum int num. And let's go ahead and block in the function. Now, again, feel free to follow me. Follow what I'm typing out here.
Okay.
And there's a lot of ways to do this. If num is greater than 0,
Okay.
because we need some sort of control,
I think that's the only part I got right.
I'm going to, I kind of want to do a print here just to show you guys what's happening.
No.
All right, fine. Return num plus num plus, here we go, the sum of num minus 1.
Oh, the return.
Else, I'm going to, hello, enter key.
Oh my goodness.
Else, I'm going to return num.
Oh my gosh.
So, see, all right. So here I am, always trying to help out, but Nelson doesn't want me to even put the print line in. So let's go back up to the top and say sum equals %d. Now let's come up here and say int sum equals, and let's call on, oh, let's not do it like that's horrible. X, let's call it sum.
I was about to
No,
start.
well, I was going to capitalize it because suddenly my brain went to the world of C# programming. And let's send over 3 to test out. So now I can jump back down here and give that format specifier X. Okay.
Do you ever have that aha moment and then you go, gosh, what was I thinking?
Aha moments are good.
Yeah.
I just ran it, and it gave me sum is 6. Well, you guys told me sum was 6 a minute ago. So now, you guys, let's see, what other one did we do? We did 5, right? And you guys said that 5 was 15, I believe? Hey.
It's
So sum of 10, 55.
yay, oh my goodness.
Hey, stay out of my shed. Nice. Yeah, that's I actually love that that particular one.
Okay.
You know what I'm getting at, Thomas.
So, 3.
I know, man. I know. All right, so
got
go ahead and type it in. Make sure it runs. And then for those of you that struggled with this, what I want you to do is I want you to use this as part of your homework. I want you to, when your mind is clear, which will probably be tomorrow. Never. All right, when your mind is clear, take this right here, and I showed you guys how to do the little stack where you can actually draw your stack frames out. Do it. See what's happening. Follow the logic through. I want you guys to have the aha moments as opposed to me coming in here and just explaining it, because when an instructor explains something, it generally makes sense. It's like, well, duh, that's easy. But it's when you have to work stuff out yourself, it's like, what does it mean?
No, I can't believe like my brain didn't figure out a simple math function. What killed me. I was like, some num minus 1. Duh.
And what's the largest number that can be passed to the sum function?
The largest number.
What's the largest? Well,
Wait.
No. That's a great question because it's tricky. Because what's going to happen as we can't say, it's going to be the largest number that'll fit into an integer, because remember.
Yeah. Because the integers are smaller, and you need a double.
Oh, you just did a bitty small symbol.
You need a double.
Double?
Don't you need bigger stuff?
You might want to work with like long integers, but even then you can still run into interesting problems. As far as what the largest number is, you tell me, Thomas. What's the largest number?
Oh, Nelson said something about this before, but I can't.
Shrug. Nelson said, yeah, you're the one with the fancy CS degree.
Because don't integers have like a certain limit or something?
Yeah, they only have a certain size.
Yeah.
And MMO does just put in a very, very large number and said it didn't go so well.
Oh, my gosh.
So homework, first one is you could say reverse engineering this program. Hey, Nelson, what's up? Nelson?
What happened?
Can you hear me, Nelson?
Yeah, I thought you were saying something and then you cut off.
The internet must be wonky again or something. No, I just said first part of the homework is just making sure you understand this.
I can't believe I got by a simple math.
No worries. I do not beat yourself up, no matter who you are, if you did not get this. Please don't beat yourself up. This is me now giving you guys your first taste of a logic problem. And like Thomas said, no, this isn't simple math. This is logic thinking here. No. Very nice, Jonathan. Very nice, sir.
It got me.
But use the diagrams that I taught you how to draw out earlier to help you see what is happening. You need to wrap your head around what's going on. Because, it's understanding recursion is what is critical here. And understanding it will set you free. And we just hit a 5-hour class. That's what I'm talking about. Bring it home, baby. Bring it home. So that means Angie wasn't kidding the other day. It would have been a 10-hour
Yeah,
class.
she was serious.
I'm not trying to break it, Nelson. I'm just trying to get in as much as I can. So I'm just letting notes be taken real quick. And then Nelson, any recursion?
Fibonacci.
Ooh,
That's
that is a classic. Don't cheat because that's such a classic one. Yeah, so that's what we'll do. That's a very, very sexy one.
Okay.
So the other homework assignment is going to be using recursion again and a function. And you're going to do Fibonacci, the Fibonacci sequence. We'll put out the specifics of what we're looking for in the homework thread. And the only reason Thomas just said my favorite is because it was probably the first thing they had him do in college. And he's just going to submit the code that he's already got.
3 plus.
But I want you guys to give that your best shot. Yeah, factorials is first, Saturn. That's just so simple.
Well, you've effectively already done
I know that. I just don't. Again, you guys have already seen. Nelson loves to use the fancy words. Anytime you start doing math, people freak out, and the last thing I want to do is start saying factorials and all. But the Fibonacci sequence is extremely cool. It's part of nature.
Mm-hmm.
Just do your best to put it together. Really think about it, but make sure that you understand. It is the golden ratio. That's right. But still, make sure you understand this first example. Okay.
It's the
No, seriously, I tried to present it as easy as possible with just the 1 plus 2 plus 3 plus 4.
Mm-hmm. It's 3.
Okay, so how are we feeling? Feeling good? Feeling pumped? Huh? Come on, guys. Oh wow, our attendees went up one. That's unusual. So yeah, next week we're going to be getting into all sorts of fun stuff. Oh, when is this due? This is all due next week. The date that went up for the first homework assignment was just a misunderstanding between Nina and I. She thought that I wanted it in before tonight's second part of the class. So no heart attacks. It'll all be due by the next meeting time. Wait, MMO Dust, you're not going to be here next week or the week after? No. Oh, Disneyland? Boo. Lucky you. Are there any questions from the stuff that we have covered tonight? Again, the homework will be written up to make sure everything is explained nicely. So don't stress about that. But as far as what we've covered, tonight was, again, part 2 of week 1, part 2 of week 2. And we're still in week 2, so I don't feel bad. And we've taken a look at functions. We've looked at how to define functions. We've looked at how to declare functions. We've looked with function prototypes. We took a very brief look at how function prototypes are typically moved over into header files, and I made one. It's not something I'm focusing on, though. Not yet. We took a look at function calls or invoking a function. We took a look at local variables, and we talked about what scope was, local variable scope. We talked about the stack in some pretty great detail. We talked about stack frames. We talked about winding the stack, unwinding the stack. We showed what happened on the stack. And we moved from there over into recursion. And we discussed recursion with a couple examples, one that I coded out on the whiteboard and then traced with the stack. We demonstrated how very simple mistakes can result in infinite loops or infinite recursion calls, resulting in a stack overflow because you ran out of memory. So for just the second half of week 2, all this was supposed to be in one night too, which is still pretty funny. It's a lot of stuff that we've covered. So I just wanted to just, throw out the opportunity to ask any more questions. I'm not seeing any. I will see if I can get us an open office hours scheduled. I've got to go back and look at it because Derek's got his class tomorrow night. If anyone gets completely stuck, please post on the forums with a question. If you're not getting any help, we've got some amazing people in this class right now that have, throughout the years, have helped members on the site, like Thomas, for example. Feel free to jump in there and help someone else if they are struggling with any type of problem. And then if you just cannot get anywhere, let Nelson and I know, okay? But yeah, like Thomas just said, of course. Like I said, we've got some great members. So that's going to wrap it up for tonight. Oh, thank you so much, Jen. I owe 3D Buzz my career. How about you just owe me a margarita when we finally get to meet face to face? That shall be an awesome day, Thomas. Me buying what? That's your idea of owing it? Wow. Yeah, and knowing me, I probably will. But, guys, thank you very much for coming out tonight. It truly is appreciated, and the fact that just about every single one of you hung out to the end, and this ended up being the longest class yet, is very impressive. I really do appreciate all of this dedication. That will conclude things for tonight, and we will see you guys for sure this next Tuesday night. Keep an eye over in the lounge if I can come up with some sort of time to get squeezed in. Now, and that's important to me, but also is getting all of this stuff prepped for next week's 2 other big classes that are starting up. There's just so much going on. But that's it. So thank you guys. You guys all have a wonderful evening, and we'll see you when we see you next.
Bye.
Bye, everyone.
Goodbye.